Alright, are we live? Can you see and hear me right now, chat? Let me know. Excellent. Alright. How's our volume level too? Is it okay? Well, hello everybody. Welcome back to Paleontologizing. Welcome back to Eastern Utah. Welcome back to a live paleontological dig. Out here with the Utah State University Eastern Price Campus Prehistoric Museum crew. We've got quite a stream for you today, I think. We've got a whole bunch of students from the UK, from the University of Birmingham, who are joining us for today, and they're out here to learn how to dig up dinosaurs. So we're going to be doing some teaching and some learning and some poking around and hopefully not being too obnoxious or distracting today as these students are learning. But I'm glad you're here, chat, and I hope you're ready to learn as well. If you're here for the very first time, allow me to introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. From my office back home, going over new scientific papers, interviewing other paleontologists remotely, and answers with the chat, just overall trying to give people an insight how fossil science works. But I'm lucky enough to be out in the field for about the next week and a half here. We're digging at the world's largest, densest, most prolific ankylosaur bone bed. This is the densest accumulation of armored dinosaur fossils anywhere on the planet. It's called Lori Site out here in eastern Utah. And I'm excited to show you around, answer your questions, all that good stuff. So welcome to Paleontologizing. Just to orient you a little bit, there's the site right here. There is the eastern border of Arches National Park right over there on the horizon. If I were to walk a little bit in this direction, you might even be able to see Delicate Arch over there. But we're out here in the eastern Utah desert. The town of Moab is kind of that way. And yeah, it's good to be here, and I'm glad you're here too. Yeah. And hey, Daily Dasp, welcome. I appreciate the Midnight Moxie, but this is about the science here. Yeah, shoot. Welcome. Let me know. And hello, Claire Burr, Boba Banks, Jedi Mega Man. Hello. Crimson Carnotaurus, what's shaking? It is good to have you here. Yeah. For anybody who's new, again, we're here collecting fossils for the Prehistoric Museum in Price, Utah. So we're digging here on federal land, Bureau of Land Management, federal land. So all of the fossils that we're excavating here, we're doing under permit. And given that they are on federal land, they belong to we, the people of the United States, and thus they belong in a museum. That's exactly what we're doing here. Not just collecting the fossils, but any data associated with them too. So you're going to see part of that process, how we gather data at a site like this, how we record it for posterity, all that good stuff. And again, since I know we've got some new people in the chat, let me give you a quick primer on what kind of critter we're digging up here. So, this, I think, is the type locality for Gastonia lorimcwinniae. Gastonia is an armored dinosaur from the early Cretaceous period. So these rocks that we're digging in are about 130 million years old, and here's a nice little plastic model of Gastonia. This is the best one that I could find. So, yeah. Really spiky guy. So, Gastonia is one of the best represented thyreophorans dinosaurs in the world, meaning we've got the most fossils of this guy. Like among ankylosaurs, this is one of the best known, and that's because of this site. There's at least 40 individual Gastonia that were buried together here, all jumbled up like pickup sticks, like you'll see. It's a cool critter. Here's Gastonia burgii. This guy's maybe a few million years older than Gastonia lorimcwinniae and not as spiky, but we'll be referring to these probably throughout the rest of the stream too. And yeah, on today's broadcast, we're going to be trying to strike a balance between being engaging and interesting and not being too distracting to all of the students who've come all the way out to Utah from England to be here. They're here for just a few days, and they're going to to be exposing a whole bunch of different bones, collecting some of them, and then the stuff that they uncover, kind of cleaning up, excavating, collecting for the next 2 weeks out here. So, yeah. Let's go ahead and take a look at that quarry, shall we? Yeah. And from England, exactly, Pomes, yeah. And good stuff. And yet we will be here at the same spot, I think, for the next week and a half, Daily Dasp, until I go back to California. So yeah. And if we had the funding and the will, we could work this site for decades, maybe a century, and not find all of the dinosaurs in here. This whole hillside right here, if you dig down to that layer, you will find more of these critters in there. It's kind of a mystery why, you've got dozens, maybe hundreds, maybe 1,000 of these dinosaurs all buried in the same. It's strange. So how did that happen? We're trying to figure that out here. Yeah. You could keep digging here and digging here for a long, long, long time. We'll give you an idea of the density here. Let's go down into the quarry. So we've got 2 different pits here, which are very different.
It's of course in inches, so it's like 39 1/3 inches. I can check it against 3 meters.
There we go.
Okay.
As you can see, the quarry's a lot more crowded than it was yesterday.
Make sure the angle that's named for Jake is the
Yes, so
collector.
the angle is
Michael and
identifiable enough.
We're working on some data collection right now. Working on some mapping.
It has 11.
11, okay,
Yeah.
so let's do 10 first.
How are you doing, Josh?
Good, how are you?
Doing well. Yeah. So yeah. Our task for this morning has been trying to remove a bunch of what we call float. So these are bones kind of on the surface so that these students can continue to dig in further. But you can't really dig in if you've just got bones all over the surface. So we're working on collecting
I
those.
think Alyssa's just hanging out.
I'm helping watch. I'm keeping watch. If people look like they're, listen, I've got a task.
You can still be chatting.
I'm supporting. Oh,
Come on in, come on in.
you want to come hang out? Oh, did you want someone to party with? I'm your girl.
No, she was scared because
I'm sorry. Yeah, come on in. Unless you don't want to be on camera. It's yeah.
I'm not.
No, not at all. No, please.
Gosh, we have constant banter on this stream.
Yeah, it's
Because we're here to provide you, the people, with a great product.
You're paleo entertainment. That's our
I was told by the BBC, never, ever look into the camera. And one time I did, and they got so mad. I'm like, you can edit that out. You're editing all of this out. Come on.
Of course, this has nothing to do with any of these rocks that we're talking about. Why are they having us drive out and fish her?
That's Alyssa, everyone. Not me.
These guys are working on float, so I was just.
Anyway, so what Josh and Alyssa were talking about right there, I think I have that in the commands. There's an episode of the Walking with Dinosaurs reboot that just came out this year. Can we get a link to that in the chat?
I mean, we could bring
Yeah, it's that was filmed here at this site in 2023, and that's the very same reason why I couldn't be here until this year, is because Josh went and signed a contract with the British Broadcasting Corporation, which expressly forbade any other media.
Yay!
So now that it's finally premiered, that's over, and we can stream from here. Otherwise, I would have been working here for the past two autumns. So yeah, and what happened here? The chat just got very quiet, or we got disconnected. What's going on? Let me know that you're alive, chat. What is going on? That's odd. Why did the chat disconnect? Hang on a second here. Yeah, we're. That's bizarre. Here, give me a second here. Let me force stop my chat app and reopen. There we go. That's weird. Yeah, the chat just froze. I'm sorry about that. You know, there's so many moving parts on a live broadcast like this. It's a million different things that can go haywire. So, yeah. And I can read you, Gravity63. Yes, thank you. I had to restart the chat app. I don't typically like to use the built-in Twitch one. I use one called Dank Chat, and I've never had that issue before where it's just frozen. So, anywho, yeah. But the reason why we can broadcast from way out here in the middle of nowhere is this. I recently made this taller so we can get better signal out of it. But this is our satellite dish right here, which is, since we don't have electricity, powered by solar power. Yeah, it's quite the setup. It takes a lot to be able to do this kind of a broadcast from way out here in the middle of nowhere, but I think it's worth it, and I hope you agree. And you know, it's not much. I've got a much smaller battery and smaller panel if we want to go way out into the back country and hike in. I did a lot of that in Wyoming this year. But yeah. And Stewie Vert says Dank Chat is great. Yeah, it's pretty good. I like it a lot. And do you have portable? Yeah. 63. And Palosaurus, it is my birthday soon, on Friday. It's my birthday, September 26th. So maybe we'll do something special for that. I don't know. We're going to be doing more digging for sure. So that'll be neat. Yeah. And yeah, it is Lordy's birthday tomorrow on the 25th. Yeah, so happy early birthday to Lordy. Yeah, and yours is on Saturday. Very nice, Kate. Happy early birthday to you too. Excellent. Yeah. Good stuff. And Midnight Moxie says, is there ever a possibility of someone hiking out there and just stumbling upon a fossil? It happens all the time. Yeah. In fact, this is originally how this site was discovered in the first place. As we had the Denver Museum of Nature and Science back in the 1990s had a volunteer named Lori McWhinney. And Lori was out here prospecting with their crew, and she found some ankylosaur bones. That's typically how we find things in the first place, is you just kind of stumble across them when you're out prospecting. Justice to how technical prospecting can be, but for the sake of simplicity, let me explain how we find sites like this in the first place. So yeah, say you're after a particular group of dinosaurs or something like that, a particular kind of fossil critter. You got to find rocks of the right age and the right type. Out here in this part of Utah, these rocks are part of the Cedar Mountain Formation. So during the early Cretaceous period, Cedar Mountain is actually crazy long. It's like 40 million years. There's a bunch of different members within the Cedar Mountain Formation. This one's called the Poison Strip member. Anyway, if you're interested in filling in one of those missing puzzle pieces, like what kind of critters were alive at this time? What organisms existed on this landscape 130 million years ago? Well, you go out and you find rocks of that age, and rocks of the right type. They have to be set. And you walk along and you stare at the ground, and you pick up little odd pieces and stuff like that, and you're looking for a bone. You typically wouldn't do that here on the flats. You'd go often along hillsides and stuff like that where there's a lot of erosion. So you're looking for bits of fossil that have eroded out of the hillside. They're starting to tumble down. You follow the trail up, you find the source, and you dig in. And in certain cases, it turns into just a bonanza of bones, like we have here at Lori's site. So Lori McWhinney discovered this site back in, I think, the late 90s, and turned out to be a new species of Gastonia dinosaur. And it was named Gastonia Lori McWhinney. It was named after her because she found it. So that's quite the honor. Some degree of immortality I think she's achieved in finding this dinosaur and it being named after her. But yeah. So she was working with the paleontological crew, and she knew what she was looking for and everything. But there are regular folks all the time, non-paleontologists, non-scientists, who end up making really important discoveries too. People who are out hiking or walking their dogs or bird watching or hunting or whatever. People make exciting discoveries all the time when they're out in the wilderness and they just happen to see something unusual sticking out of a hill or something. Do that too if you're ever hiking around in a fossiliferous area. The important thing is that you take a picture, and if you can, you don't want to destroy it, and take a GPS reading. It's easy to do with smartphones nowadays, and email it to a nearby paleontologist or geologist. A lot of states in the US have a geological survey with people on staff. It's their job to respond to emails like that. And it could turn out to be something really important. Countless stories of just like, normal person walking around, they find something weird, they call it in, send an email to their local paleontologist or geological survey, and then it's a phenomenal discovery. It happens again and again and again, all the time. But yeah. And I've been to Moab a few times. It's special. It is pretty special, Midnight Moxie. Absolutely. And fossiliferous. There you go, Wombat Hole. Yeah. Yeah.
I think the stream's coming over.
What's that? Yeah.
What?
So we'll clean it up for a second if that's okay.
Yeah, we can clean it up. Lock it in, y'all.
Hey,
chat, lock in.
Is the trailer locked?
Sorry,
the front is not, the back is.
I did not know. Looking good, by the way. Yeah.
Very on there, so I'm gonna bring that up.
Yeah, I also have a couple in my backpack. But...
See, so it's Macy, right? Yeah. Check out Macy's hat, Chad. Badlands Dinosaur Museum right there. Yeah. So Macy actually worked with Denver and Liz out in Montana for last 2 years. Is that right?
Yeah. And
Very
this
cool.
isn't a shameless networking plug at all.
No, definitely not. No. Yeah, we just did some streams from there back in February. So yeah, you remember the Badlands Dinosaur Museum, chat. You remember Denver. Yeah, so Macy was working with them. Very cool. Small world, Macy, originally from Florida, right?
Yeah.
And now you're going to the University of Birmingham?
Yep.
Very cool. Yeah. So again, small world in paleontology. It really is.
Yeah, we all know each other.
Yeah.
Go for the internship at Denver and you can come back out here again.
Yeah.
Good idea, Josh.
But yeah. When you got a second, Josh, we actually have a question from chat.
I have a second.
All right. Beautiful. Yeah, somebody in the chat was curious how often regular non-paleontologists or non-geoscientists end up making important fossil discoveries. And it was all the time.
Yeah. 3/4 of my dissertation was based on fossils found by amateurs.
Nice.
So I'd say they're a little. No, and yeah, and the thing is too, it's discoveries in the field, but it's also work in the lab too.
Yeah.
We're out here. Hey, the field work. It's fun. It's sexy. Other than all the sweat. The prep work, the collections work on the back end, is just as important. Ground.
They wouldn't get published if they didn't get prepped.
Exactly. And like the first critter I ever named was a turtle, and
what was the name?
Arvinacheles goldeneye.
Nice.
And the goldeneye part is based on
Nintendo 64 game, right?
Goldeni. Is named after Jerry Golden, who is the guy who prepared the fossil.
Nice. Okay, very cool.
Retired geologist who volunteered at the museum and prepped it out beautifully. So
nice.
Yeah, I think it's great, especially like whether it's this species of Gastonia that was honoring the person who discovered it, or the person who prepped it. I think it's a great way to honor those folks that aren't paid paleontologists, to be able to involve them in the science. And I've had some folks, we've got one volunteer who discovered a site last year. Yeah. in the Kaparowitz Formation, and I asked him, all right, well, if this is something new, because it's from a horizon that doesn't have as much yet, it's kind of low in section. Say, hey, if it's something new, you want me to name it after you? And he's like, no, I want to be on the paper. And I was like, yeah, all right. He's a big numbers guy, so he can run some stats that my my little rock jockey brain can't do.
I'm right there with you. Yeah.
But yeah, you know, I like to give people that option. You know, you want to be involved as an author, you know, or whatever, because yeah. You know, there aren't enough people that are actually paid to do this, and you know, we really rely on students, and that is a really nice plate that she's got
Wow,
there.
look at that, yeah.
I just realized. I was
Just
like,
seeing the perimeter
squirrel.
of it right there.
That's beautiful.
This is large. I haven't found 3 of the edges.
Yeah.
Big one right there that my shadow finger is pointing towards. But then this thing right here, that's pretty.
Yeah.
Oh, yeah.
Would that be what Jim would call a splate?
No, splates go from pretty flat to being spined at the end.
Okay.
This thing is kind of tapered all the way. And actually, now that I look at it and looking at this leading edge shape,
Yeah.
so I brought some bones. I told Danny this.
Yeah.
Brought some bones that are already prepped out that we dug the first year. And there's one that we thought was a caudal plate while it was in the ground. Looked exactly like this. Prepped it out. It was a dorsal spine.
Oh,
So
nice.
actually, looking at this base end and the leading edge right there, that's a dorsal spine. So that's
Very
one of
cool.
the dudes that comes off the top.
Yeah, nice.
We have all of one of those from the site
Excellent.
in our collections at least.
That's way better than I could have hoped for. All right.
Yeah, that's the find of the trip so far.
Let me grab the visual aid and we'll point out, what this is supposed to be. Trying not to get tangled up in that rope.
What part of Florida are you from?
I'm from Tampa, but I live in Miami.
Okay, cool. I'm from outside of Birmingham, Alabama.
Okay.
Not Birmingham.
The second Birmingham.
Yeah. The other
Birmingham.
I'm not from Birmingham. I'm from Birmingham.
Again,
Anyway.
our Gastonia here, would you care to point out?
Yeah, so it's not one of the bigger ones. It's
Yeah.
probably one of these,
Okay.
something like that.
Nice.
Assuming this is real placement. But
Yeah.
it's one of the what we call the dorsal spines.
Nice. Very cool.
Yeah.
Yeah.
Can I get your little charcoal?
That's exciting. What's that? Oh, yeah. Go for it.
Yeah.
So that's one of Jim's figures.
It's
I'll
actually
just find
really.
it online then.
I can send you a digital copy.
Thank you, that'd be cool.
But I actually like it because it kind of shows just how much spinier this one is compared to bird's eye. That's cool.
Gastonia. Oh yeah.
Yeah, so basically hers is that one right there.
This big of it she got.
Uh-huh.
That's exciting.
Nice.
And I guess we do have
Did he
the
show you?
base of so this is Gastonia bird's eye versus Lori McWhinnie,
Okay.
and yours is probably that morph right there.
Wow. Okay.
The bigger ones, I actually do have a couple of just the bases, but not a whole one. But I mean, that's basically a whole one of these. So
Nice.
That's
Very
so not
nice.
what I was expecting from today.
yeah. Oh yeah, and you guys, I showed you those down there, and that's one of the bones I showed you guys, the
Yeah.
one that's really curved. Yeah, that's what you got.
Nice.
Exciting.
Heck yeah.
So that's the sort of thing that's lurking around in here. So like,
yeah.
Kitty, just under your scoop, there could be another one right there.
Go for it, sorry.
Shoot, you never know.
Hey Josh, just out of curiosity, how big are we going for mapping? Is something about that big enough?
But yeah, I hope that makes sense.
So then that,
I'll leave that visual aid down here actually, so they can reference that if they'd like to. And let me get some water before I forget. It's in the 90s today. It's a little bit toasty. So, yeah. Oh, WRG says, Alyssa, that's my bestie. Let's go say hi to her. Then I'll get some water. Uh-huh.
So now we're into
So now we're here to here.
Let me get out.
Here.
Do
Hey,
you
Alyssa.
have any?
You've got a bestie in chat saying hello to you right now.
Is it Rhonda?
I don't know, WRG 102? Yeah.
Does it say WRD?
WRG.
G.
Not sure. Oh, it's Whitney.
Whitney! Whitney Greaves.
Wait, Whitney Greaves?
Whitney.
Whitney, I know you. Yeah, our resident
The
paleobotanist.
bestie. She's like, bring us on.
No, that makes sense. The initials now. Yeah,
Miss
cool.
Whitney.
Yeah, we miss you, Whitney. Hope you're doing well.
Wish you were here.
Yeah. Hope things are going well out on the East Coast.
What up?
So I'm doing nothing over there.
Yeah, she's busy watching the chat instead of reading about plants.
Yeah, we need you to work on
Watching
the first. So project for you, Whitney. We need to know what the first flowering flower would have looked like from the Cedar Mountain Formation. Specifically, I'm assuming it would look like a magnolia, but. Josh and I were talking about it, and he's like, "Ask Whitney."
Yeah. Well, some of the
She
earliest
just
ones.
she wants to know because she wants to get it as a tattoo.
Yeah.
Oh, that makes sense. Yeah. Nice. That's cool. It's cool to like get a tattoo that's based on cutting edge science as well.
Right?
You know.
Like then you can actually say like these are the things because Whitney and my husband are like kindred about plants.
Yeah.
And so we spend a lot of time. You find dinosaurs on accident when you're looking for plants in the Cedar Mountain
Yeah, yeah.
Formation, and that's really where a lot of really cool plant science happens because angiosperms pop up.
Yeah,
and
yeah.
everything really changes on the in the landscape. So, but flowering plants are really hard because you can't figure out they don't fossilize.
Yeah.
And so there's renderings of what they could be, and so you have to trace back like Whitney and Jeff kind of science
Yeah, yeah.
of like what genus lives now and what can we trace that back to that has been discovered. And it's too much science for me to cram in a week.
Yeah.
if
Well,
you're
also
bored-
it is cutting edge stuff too. Like it's not. It's science that's still in progress, and so much of it is still a blank space on the map, essentially.
Yeah, they just found giant petrified wood logs over like, kind of toward Farron, above the Mako,
nice.
like in
Yeah.
the Mako Shale, like Farron sandstone.
Uh-huh.
And they're flowering trees, and they're huge.
Uh-huh.
And so I'm trying to figure out what that flower would have looked like.
Right.
But any flower will do, Whitney, from the Cretaceous and either the Cedar Mountain Formation or near the Farron sandstone.
Whitney says I'm literally stopping in the sidewalk on my walk home, looking at my notes.
Nice. She has my Insta, so
Yeah. Excellent.
perfect.
Cool. Here, let me get some water, like I promised myself I would do, before I keel over here. But hey, Nelf, how are you doing? Hello. Yeah. Yes, Claire. Let me get some water. This is cool. Josh was saying that when the students show up from the UK, they're going to be uncovering all kinds of stuff, and they're going to kind of set us up for the next 2 weeks, collecting and excavating, and it's happening. This is exciting. We're going to have our work cut out for us in the best way. Yeah. And sky looks amazing, says Geeks Tour. Looks like pretty good weather out there. Yeah, it's hot right now. And it's an almost cloudless day. Yeah. There's some clouds over there on our eastern horizon. Some to the south, and that's it. It's hot today. We had a bit of a cold front move through over the last couple days. Our high yesterday was like 80 degrees. It's going to be into the high 90s today, probably. That's Fahrenheit, by the way. Yeah. So I got to make sure that we're staying hydrated. Especially all the students from England. Got to make sure that they're drinking enough water because, like we discussed yesterday, England is not a desert country, as one learns from the film Lawrence of Arabia. Yeah, got to make sure that you stay hydrated out here and hang out in the shade if you can. And Flickster says, a lot of people think dinosaur hunters are old and sort of not humorous. Really? Josh is hilarious and makes you want to learn from him. Like you guys make dino hunting sound fun and yet serious work. I'm happy. I'm happy you feel that way. Yeah. It's good to keep morale up in the field. It's good not to take yourself too seriously. Yeah, field paleontology can be a lot of work. It can be stressful. It can be tiring. It can be tedious. But things go so much easier. There's so much more fun if you can make sure that you have fun doing it, A big part of it is having the right attitude and, like I said, not taking yourself too seriously. Yeah. And... Oh, look at my response. I'm sorry, Whitney. Let's see. I don't know about the cedar. Ambarella is theorized to be one of the earliest flower types because it's the most basal and related to conifers, but I could do some more fossils. Cool, Whitney. Let me go tell, sorry I missed that, but let me go tell Alyssa. I'll read that out to her. Yeah. Here, Alyssa, we've got a more detailed response from Whitney. If you want me to read it out?
That was fast.
Yeah, she says, I don't know about the Cedar Mountain Formation specifically, but genus Ambarella is theorized to be one of the earliest flower types because it's the most basal and it's related to conifers. It's related to interesting. But I could do some more digging on actual Cedar Mountain fossil plants. So I guess she'll look into that for you.
That'd be sweet. Thanks, Miss Whitney. That'll give you something to do in Connecticut. I asked her, I was like, what are you going to do over there? She's in grad school. So we're happy that she's in grad school. So where's that?
Yeah. Awesome. Thank you, Whitney.
That's super helpful.
Thanks for emphasizing. I'd missed that. I'm sorry. It just cruised by. For those of you wondering, Whitney, who's this? Check out our VODs. You could find them on YouTube from this past summer in Wyoming. I did a couple streams with Whitney collecting fossil plants. We called her our resident paleobotanist. So yeah, she studies fossil plants. She's in grad school right now doing that on the East Coast. And yeah, she's worked with some of the people here for a good while. And yeah, Whitney's cool. I wish she was here right now, but she's got more important things to do apparently. Evidently, out there in school. Just Floof says, so these students are voluntarily taking this trip to brush dust off of fossils in scorching heat? Well, I mean, yes. That's, well, we got these shade tarps for them.
Just got that.
Yeah. Well, I don't know. They want to be paleontologists, and they're doing the thing, you know? Shoot, it's... Yeah.
Get out of here. Get out.
Anywho. So excited for the students. I should have stowed away with them. This is Mothproof KT. There you go, yeah. Here, let me catch up to the chat.
Oh, well, Professor Lively.
They are indeed actually doing the thing. It's true, Just Floof. Yeah. And Mauser's Fury says you're always just walking around instead of showing us what's happening. Well, that's the thing, is that I don't want to get too up in people's faces. You know, there's work occurring. I'm taking a break from digging so that I can walk around with the camera, answer questions, stuff like that. I don't want to butt in too much and distract people as they're trying to do detailed work, excavating these specimens, collecting data, that kind of thing. But we will go take a look at the other quarry right here. That one's a bit more spread out, and so we can probably hang out for a minute, kind of show you what's going on there. Yeah. And Palosaurus says, this is so cool. Honestly, we're so lucky to have... I appreciate that, Palosaurus. Just Floof says, what are the requirements for volunteering? It depends what crew you're volunteering, you're trying to join. But yeah, with the museum here in Price, Utah. Well, what other requirements? Let's ask Josh real quick.
I guess I haven't checked my backpack.
Josh, what are the requirements for volunteering on a crew like this?
Well, you have to be 18 years of age or older, and like cool dead stuff.
Okay.
That's it.
Pretty stringent requirements.
Yeah,
though.
we do have you fill out a volunteer application, and so we guess can't take felons when they do the background check. So no felony convictions.
Okay.
I was gonna make
It's a good thing I didn't fill out the form.
Yeah, there you go.
Just kidding.
But yeah, 18 years of age and older, and you know, an interest in this stuff, and you know, some ability to hike through the desert. And take direction.
Yeah,
Yeah, that's probably another thing that would be good. I don't normally attract people that can't take direction though, so
right, yeah.
I don't have to worry about
people
that.
People are too high-strung or too hard-headed. They might not get along with you in the first place.
Nope.
So,
Not at all.
Yeah, that's a good like selection mechanism there. Yeah.
Yeah.
And you have to be able to get yourself out here too. So like,
Yeah.
you know, Josh isn't gonna drive out. Chooses to pick you up to bring you here or anything. Like you have to find your way
Yeah,
out. Out here in the
yeah.
first
I mean, I
place.
might drive to.
Because Whitney's there.
Like if folks are flying in to say Salt Lake City, we can work
Yeah.
out something like, Michael
Yeah,
riding
yeah.
down with some folks because we'll oftentimes have volunteers coming down from Salt Lake City.
Yeah,
so,
yeah.
You know, we'll work something out. Usually though, you get yourself to Price or to the dig site one way or another, and you don't have to pay anything. We cover your meals and your water. You just have to bring your personal stuff,
Camping gear.
and
Yeah.
I really don't have because folks are like, oh, I'm just insert a profession. I don't have any training in this. Well, that's my job.
Yeah,
I
exactly.
can train you to do just about anything in a few days that you need to do as a volunteer out here.
Right.
So yeah.
Yeah. Awesome. Thanks.
Yeah,
Jeff.
so if you want to come out, shoot me an email and I'll send you a volunteer application. And that's more just liability and make sure you're not a felon. And you're welcome out here.
Awesome. Thanks, Jeff.
Yeah, you're welcome.
Yeah. Yeah, and if anybody wants to, maybe you don't have the ability to come out and volunteer to help. If you'd still like to contribute, we accept donations too. We've got some links there in the chat if anybody would like to contribute financially or purchase something off the Amazon wish list or something. We need to get some more items on that wish list, by the way. But yeah. Well, thank you, by the way. I don't know if he's in chat right now, but Kennedy 104, thank you so much for your donation yesterday, helping us get some field gear when we were in town last evening. Really appreciate that. It makes a difference. We've got a bunch of tools that these students are using right now that you helped us purchase, so thank you very much for that. That's a big deal. Yeah. Yeah, it was pretty surprising, Claire, but very generous. We really appreciate that. Yeah. Good stuff. So yeah. Poke around over here for a minute. Take a look at the other quarry.
Oh no, don't worry about it. It's not mission critical yet.
Other quarry, other pit, whatever you want to call it. This is all one contiguous site. So this pit right here and that one over there, this is the same horizon. So this is a continuation of the same bone bed. If you were to dig in right here, below my boots right now, a whole bunch of other specimens, more of this ankylosaur dinosaur just under the surface. Right now we have the wherewithal to dig in 2 different places at once, but if we had a crew of 100 people, we could dig into this whole hillside and just find, thousands of Gastonia fossils. But we're doing well right now. Yeah, this is what we can achieve at present. And
Thank you very much.
Without going hard.
oh, and they're taking a look at a rather risque t-shirt. This is a joke thing. I don't think I can show that on stream. But yeah, we'll see. We'll wait until after they've looked over there before we go over. And Mauser's Fury says, I'm surprised it's not actually a thing that's happening. Well, the thing you got to understand about paleontology, about fossil science, is that we tend to be a very underfunded kind of discipline. Despite the tremendous public enthusiasm for extinct animals like dinosaurs, it's often really difficult to find money to actually dig them up. It's even harder to find the money to clean them in the lab and study them and that kind of thing. So, yeah, it's tricky. Paleontology is one of those disciplines that's very underfunded. That's why all of us here, except for Josh pretty much, are volunteering. Including myself. I'm not getting paid to be here, except through these live streams, obviously. This is how I make my living, but I'm not getting paid to actually excavate these fossils or record data or anything like that. We're often operating on shoestring budgets, You know, it'll be a few $1,000 for a summer. That's our budget for, you know, for fuel and food and supplies and everything else. Yeah, it's we're always in need of funding, you know. Which again is surprising, because you think about how much people love dinosaurs. You think about how much money dinosaurs have made for movie studios and video game production companies and toy manufacturers and stuff. That total's got to be in the billions of dollars, but we don't see like any of that money. It's the people who are actually making these discoveries, digging up the dinosaurs in the first place, telling the world about them. I'd love to live in a world where it's a bit more equitable there, but that's not how it is at present, you know. Yeah. And how much first aid knowledge do you need to go digging? Not necessarily any, Miss Art Rules. Yeah. We've got some people on the crew who have had first aid training. At one point, I was I don't know if I had a full certification, but I was trained in wilderness first aid way back in the day, when I got my first paid gig doing field work. But yeah, we've got some experience, and you know, we've got a first aid kit on site, all kinds of stuff like that. Honestly, it's prevention is one of the things that we try and do so that we don't have to worry about doing first aid. If we can prevent injuries in the first place, you know, by doing things like drinking enough water, looking where we're stepping, stuff like that. Putting little plastic caps on the bits of rebar that are sticking out of the ground so that people don't get impaled on them, stuff like that, you know. That's what we try to do, all that stuff. Yeah. And I agree, Just Floof. Yeah, home ownership, a fading dream, especially here in the United States. But yeah. But yeah, I'm right there with you. Yeah. See if we can go jump into the other pit over there. Yeah, you can keep that in the quarry there, Alyssa, if you want to. Yeah, thanks. All right. So here is our second pit over here. The alphanumeric designation for this one is TW for tweener, because this is our in-betweener pit. There's one over here. There was another one years ago on the other side. Now it's just two that we're working right now. But let's go into the tweener pit over here. So let's see. So this side is a lot different from the other one. The bone is a lot less densely packed. Tend to have larger elements like limb bones and stuff like that. Very different from over there. Poke around here a little bit. And you see we've got some big jackets. Some of these are left over from last year. And a few of these, I think we saw yesterday, being put together on stream. So, yeah. It's interesting. There's a story to be told here with less densely packed bones over here that tend to be larger, heavier. Might have something to do, well, it certainly has something to do with how these bones were deposited in the first place. So we'll talk to Michael about that in a little bit, who's working on the taphonomy of this site. But for the time being, we'll just kind of poke around and take a look at a few things. So you can see we've got a bunch of bones over here. They're pretty dense, but not quite like the other side.
Probably put it back over where they.
And yeah, nice. Is that a vert right there?
I'm not sure. We're treating
interesting.
it as if it is, because we're not totally sure.
Yeah.
Maybe. Could be a soil nodule, difficult to say.
Is it okay if I introduce you to the chat?
Sure.
Yeah, so this is Dr. Susanna Maidmont, who, if there is a world authority on stegosaurs...
There is.
And that's her right there. We've watched some of your videos on stream before. you gave a talk at one point that made it onto YouTube about stegosaurs as a group, and every time somebody asks me about stegosaurs, they want more information on them. Ask them the link to that video. It's a really good primer on that whole group. So, talking earlier about Spicomelus. So, this is a dinosaur that we covered. There's that new paper that just came out. This really weird, spiky, early ankylosaur animal, and yeah, Susie here is one of the people who brought this critter to life, and right now,
Yeah.
so
It's nice
yeah.
to be digging some other ankylosaurs, albeit
right?
much younger.
Exactly. Yeah. How old is Spicomelus again?
It's about 165 million years old. So
165.
it's Middle Jurassic. It's the oldest ankylosaur that we have in the fossil.
Nuts, and it's from Africa
Yeah,
too,
only one we know from Africa.
which
yeah.
is bizarre. Yeah. Do you think that group might originate in Africa? I mean, that it might point in that direction if that's.
I mean, yeah, there's this idea that we have these southern hemisphere group of ankylosaurs.
Parankylosaurs.
Yeah, absolutely.
Yeah, yeah.
And I mean,
Yeah.
we didn't find that when we did our evolutionary analysis.
Uh-huh.
But I think that we haven't answered the question really. And
Yeah,
of course, basically the whole of Africa is unsampled. I mean, we have
Yeah.
South Africa, we have some good sampling, Tanzania,
Mhm.
but very little of Africa has been sampled for fossils really.
Right.
So I think there's the potential that we're going to find loads of cool stuff in the future.
In your humble opinion, why are Thyreophorans, armored dinosaurs, the best dinosaurs?
Well, I think they're really interesting because they're really early, so they split really early from the rest of the herbivorous, the ornithischian, bird-hipped dinosaurs. But also, so this means that they can tell us loads about kind of the very early evolution of the group and how they kind of radiated and came to dominance. But also, I mean, they have a body plan totally unlike anything that's alive today, don't they?
Incredibly weird. Yeah.
Yeah, extremely weird. And so I think, I just think they're really kind of fun and interesting. And of course, actually, I think all of the ornithischians are the coolest dinosaurs, by the way. But, we have these things that we have all these crests, these frills, these horns, these armor plates, these structures that we're just not seeing in any animal alive today.
Right, yeah, there's no modern analog for a lot of these things. It's
not
just
at all.
Utterly mysterious.
So I think, we have the potential to learn loads about their kind of, social behaviour and locomotion and stuff like this with all these dinosaurs. So yeah, I think they're
Very
a cool
cool.
group to work with.
Thank you so much. Appreciate it. Yeah, we'll pop in again in a little bit, I'm sure, but around and see what else is going on throughout the rest of the site. Thank you.
Yeah, sometimes with the dirt, like if you...
Let me answer some more questions too. Let me come out from under the shade tarp. Fleas have accumulated. Yeah. And Daily Dasp. We can ask Susie if she's had some other friends. She was talking about some of them. I'm not sure how many she's willing to share, but there's some exciting stuff coming up about Spicomelus that I can't tell you about. But that animal is going to be in the news again soon, I think. There's more exciting stuff coming up for that critter, for sure. Yeah. Yeah. And Alexander just got a new update in visuals of Brian's saber target. Oh, very cool, Alexander. Did he deliver that yet, or is he working on it in his studio? Because I think we'll be doing a special stream at some point showcasing that once it gets delivered to the museum. That's for anybody wondering. Brian Eng is a really well-known paleo artist. He does 2D and 3D work. One of the museums that I work with back in the Bay Area, the Children's Natural History Museum of Fremont, at the Math Science Nucleus in Fremont, California. Yeah, Brian is working on some life-size sculptures of saber-toothed cats and of ground sloths for that museum. They are going to be superb. And we'll be showcasing that on stream at some point, I think, once they're finished. But yeah. And saw a buffalo skeleton. Looks like it has a frill. Oh, Foggy Planet, are you talking about those elongate neural spines in the shoulder region? It's absolutely a thing on bison in particular, the American bison. Yeah, that's a big fleshy hump. So that's muscle attachment for these big muscles and stuff like that, soft tissue, maybe tendons as well, that run from the crest above the shoulders down to the head. They have massive, heavy heads, and that structure there, their vertebral, what we call neural spines, the pointy part that comes off the top of the vertebra. It's called a spinous process in humans, but in other vertebrate animals, it's called a neural spine. Those are super long in a bison, right above the shoulders, and they form this fleshy hump that helps them hold up their head. It's pretty cool. And update showed the bust of the saber-tooth. Very cool, Alexander. That's going to be awesome. Kenny HY, hello, hello. Generating views. What's shaking? Good to have you here. Yeah. And Daily Dash says, so why do paleontologists keep specimens secret before they reveal it in news? I just always wondered if it was suspense or confirmation. So it depends. Some paleontologists are very open about the things that they're working on all the time. They're just excited to share them, and they kind of trust that nobody's going to scoop them. Papa Jim is like that. Jim Kirkland is very open about a lot of his stuff, just eager to share it. You know, he's very trusting there, but I think, I don't know, I really like that approach. Other researchers might be a little bit more cagey about the things that they're working on because maybe somebody else is working on something else that's very similar, and maybe they're even working on the same kind of critter. You want to get yours published because priority counts for a lot in science. Say that two different discover the same kind of dinosaur, you know, on opposite ends of the state, and they're both going to publish on it. The name that gets published first is the name that gets to stay. So, yeah. Also, there's sometimes scientific journals, the publications in which we, you know, present our work, the journals that we publish in, sometimes they have specific rules. These publishing companies will be like, hey, you really can't share this stuff until we publish it. Some of them are really strict about that. So there's a number of different reasons why researchers might be cagey about things before they go to publish them. But in paleontology, it's not as I feel like that's not as much of a factor as it is in other branches of science too. Yeah, I don't know. We present a lot of things at scientific conferences, and you know, it kind of gets semi out into the public before it gets published. But yeah, I don't know. It depends. It's very much like a case by case thing. Different researchers will have different thoughts and feelings on how cagey they should be, how secretive they should be about what they're working on. At the end of the day, we want our science to be public. We want people to be able to see and appreciate what we work on. We want everybody to be able to, you know, enjoy the discoveries that we've made, to be awed and inspired by them. Sometimes that requires a bit of a press embargo beforehand, though. You know what I mean? Yeah. And academia can be crazy competitive. It's true, 401. Yeah. And Generating Views says, what's your favorite anatomical difference between modern day mammals and old school dinosaurs? I like old school with a K. Yeah. You mean like Mesozoic dinosaurs, the non-bird dinosaurs. I like how you said that. I think maybe one of the coolest differences between modern day mammals and Mesozoic dinosaurs is that dinosaurs all hatched from eggs. As far as we know, every dinosaur that ever lived hatched from an egg. And as a result, they had potentially very different ecology and biology than mammals. So think about this. When an elephant has a baby, that baby is very large. Like a baby elephant weighs more than I do. It's hundreds and hundreds of pounds. That's not the case for dinosaurs. The very largest dinosaurs that ever lived, like these gigantic long-necked sauropods, critters that could be longer than a whale, they might weigh close to 100 tons or something like that, if we're being generous. They hatched out of eggs. No bigger than a soccer ball or a football. And so they had a tremendous amount of growing to do. Baby mammals do. And so, as a result, dinosaurs are a very different kind of creature. Like dinosaur-dominated ecosystems may have been very different in the sense that as these baby dinosaurs are growing up, they might be living in different parts of the environment than the adults are. They might be eating different kinds of food than the adults are eating. It's like they're a different kind of creature from the adults. It's almost like one dinosaur species is occupying a whole bunch of different ecological niches as it grows and matures. We don't have that in mammals today. With mammals, it's one species per niche. A niche is an ecological job. So like, I don't know, think about different big cats out on the African savanna. You have lions, which are these, big predatory animals. They live in packs. Cheetahs are another big cat. They tend to be more solitary. They're a fast pursuit predator. They're eating different prey than the lions are. So cheetahs are going after gazelle, whereas lions are going after wildebeest or zebra or things like that. Then you have leopards, which come out at night. They sleep in trees during the day. They're much more secretive. They're also solitary. So these are different niches, different ecological jobs. It's like a different job that you do in your environment. And with mammals, there's one job that they do their whole lives. So mammals give birth to live young. For the most part, they don't lay eggs. And they feed their young with milk, which means that the babies are feeding on milk until they're big enough to eat whatever the adults are eating. They're not going off doing their own thing, living in a different part of the environment from the adults. We think a lot of dinosaurs were probably doing that, which means that dinosaurs were probably occupying multiple niches throughout their lifetimes. It's almost like, for some intents and purposes, it's almost like they're a different creature at different stages of growth. So very different from what we see in today's ecosystems that are mammal-dominated. This is something that I think doesn't get discussed enough, even among dinosaur paleontologists. And I think it could help explain a lot of different things about the dinosaur world, about the Mesozoic, about how ecosystems worked back then. Things that are, so far don't seem to make a lot of sense. I think some of the solutions might be in that thought, that dinosaurs are doing what we call ontogenetic niche partitioning. So they're partitioning niches. They're like splitting up, different ecological jobs throughout their ontogeny, throughout their growth and development. Does that make sense? Yeah. Mother Toad's Nursery Rhyme says, never thought about that. Oh yeah. It's cool to think about, Something I think doesn't get discussed enough. Yeah. And, but yeah. And there you go, Alexander Morrison. Yeah, American alligators and other typically large croc species are a huge multitude in body size versus mammals. Yeah. And crocs do some of this niche partitioning too. They do exhibit a good deal of parental care, which we know some dinosaurs did, and we're not so sure about other kinds of dinosaurs. But, yeah, like a little baby Nile crocodile is not going to be feeding on wildebeest crossing a river or anything like that. It's not going to be taking down big ungulates as they're trying to make their way across the Mara River, for instance. A baby Nile crocodile is eating things like little fishes, minnows, frogs, snails, bugs, a lot of bugs. They're eating something different from what the adults are eating. That's interesting, And their teeth and stuff like that change shape as well as they grow and mature. It's not super dramatic. It's not as dramatic as it is in some Mesozoic dinosaurs. But it's, it's something to think about. Yeah. Something that mammals don't do. Yeah. And Daily Dasp says, I wish I could say evolution is cool without starting an argument in public. Well, yeah. It's lousy that here in the U.S. especially, so many people are so afraid of the idea of biology. They're afraid of the idea of living things changing over time. They're afraid of the idea of evolution. But that's part of why I'm doing these streams, It's part of why I do science outreach, is to show people how cool this stuff is and that they shouldn't be afraid of it, Yeah. And Ms. Rule says, can we find out how long an extant dinosaur takes to grow from embryo to break open an egg? An extant dinosaur? Yeah. You mean like birds? Of course. There's been lots of studies on that. Also, we've got literally billions of extant dinosaurs, chickens, hatching out of eggs, every year. Literally billions of times that happens. So the life cycle of chickens is pretty well understood, I think, at this point. And that can be, in a lot of ways, a good analog for extinct dinosaurs. Things like other theropods, things like sauropods, ornithischian dinosaurs, etc. Yeah. What do we know about the growth rate of dinosaurs? That's a great question, Dread Raining Views. The best way to figure out how dinosaurs grew is what we call histology. So you take the bones, you cut them open, and then you take a thin section out, and you can see the growth rings inside, just like in a tree stump or something like that. This is a little bit of a simplification, but yeah, you've got lines of arrested growth, what we call lags. They're like the rings in the bone. And that show you essentially how long it took for these animals to grow. We can tell how old they were when they died, that kind of thing. And for a lot of dinosaurs, they grew very rapidly. It's kind of nuts how fast they grew. So a dinosaur like, I don't know, let's take a classic like Tyrannosaurus, T-Rex, for instance. We know that they grew tremendously fast. They could be putting on, what, I think, was it something like 10 pounds every day or something like that when they're going through a big growth spurt? And we actually know we can graph out on a graph what their growth rate looks like. And so they grow really quickly when they're young, and then they slow down a little bit, and then they have a huge growth spurt in their teenage years where they're not just growing in length, but they're also bulking up. So like a teenage Tyrannosaurus, an adolescent T-Rex would be very slender, long-legged, probably a really fast runner, and then they hit this growth spurt and they really pack on the pounds. They become a big, bulky, probably much more slow-moving predatory animal. And again, it's like I was talking about earlier. It's like you have a different kind of creature at different growth stages. It's the same animal, but it's not quite as dramatic as like a tadpole turning into a frog over its lifetime, but it's still pretty dramatic, especially for an amniote, for a non-amphibian tetrapod. Among reptiles, dinosaurs, and among mammals too, especially, dinosaurs have crazy ontogeny, like crazy changes throughout their growth and development through their ontogeny. But yeah. And let's see. Did I miss any other questions? And Geeks Tour says, I've been watching the flocks of blue jays migrating the last few days. I'm assuming the belief is that most dinosaurs migrated. Do we have any idea of which dinosaurs migrated the furthest? That's a great question. This is something we're still figuring out. It's when you've only got fossils, it can be difficult to tell behavior, you know? When you're looking at primarily bones and teeth and claws and stuff like that, inferring how these animals actually lived can be quite difficult. However, I was just talking about this the other day, so apologies if it sounds repetitive. We do have strong evidence that certain kinds of dinosaur migrated. Take Maiasaura, for example. It's this big duck-billed dinosaur from Montana, and we have strong evidence that they had nesting rookeries, nesting colonies. The adults would gather and, all lay their eggs in nests in the same spot, in the same area. And so you just had a big nesting colony. There's a lot of birds that do this today. And all animals, they would completely eat up all the plants. They would have to be able to migrate in the group. And then later on, they would migrate out. They would disperse across the landscape. So we know that dinosaurs like Maiasaura were migrating in herds that were hundreds, maybe thousands strong. It would have been a sight to behold, to go back to the late Cretaceous period and just watch these animals migrate across the landscape, these critters that are roughly like elephant-sized. Thousands of them marching across the floodplain would have been pretty wild to see. We've got similar evidence for dinosaurs, or horned dinosaurs, critters like Centrosaurus or Pachyrhinosaurus, that they migrated too, because sometimes we find them in huge groups. So there'll just be 100 or 1,000 individuals all in the same spot. And that might be that they got caught in a flash flood, or they were trying to cross a river when the water level was too high and the water was rushing too fast. We see the same thing in wildebeest today, out in the African veldt. It's cool when you can make those parallels to the modern world, you know? So these wildebeest, they have to migrate across the landscape in order to find enough food to eat. So they'll kind of follow the rains and they'll follow the plant growth. They'll make sure that they're going to areas where there's enough to eat. So they got to move tremendous distances, and sometimes they have to cross big raging rivers, and a lot of them will drown sometimes. They might get into kind of a log jam as they're trying to cross, and they'll trample each other, and a lot of them will drown. It happens. And we think the very same thing was happening back in the Cretaceous, which is why we get maybe 100 or 1,000 Centrosaurus or Pachyrhinosaurus all packed in the same spot. And a lot of them show signs of being trampled. So their bones will have these weird conical fractures, not conical, they're like twisting fractures on them that show that the bone was broken while it was fresh. Yeah, so these animals were stepping on each other. So yeah. So we do have evidence that some dinosaurs migrated, but you kind of need big sample sizes in order to show that. We don't have that for most dinosaurs. For most dinosaurs, we only have, say, one. Even some of your favorite dinosaurs, things like, I often bring up Carnotaurus, this cool horned theropod dinosaur, the late Cretaceous of Argentina. Carnotaurus is a lot of people's favorite dinosaur. It's well represented in popular culture. Movie from 2000. It was in some of the Jurassic World movies, I think. It's all over. It's exactly that's ever been described. I think one specimen that's ever been found. Just that one. If we didn't have that, we wouldn't even know that animal existed. Most dinosaurs that have been named, most genera and species, are known from just one specimen. That is totally different from what we have here at this site, at Laurie's site. We've got, just tuning in, dozens of individuals of this critter, Gastonia, right here. Lovely armored dinosaur from the early Cretaceous. And we have dozens in this one spot. Under this hill, we've got 2 pits going right now, and they're just everywhere. That's one of the reasons why this site is so important, is we've got a huge sample size. So the more bones we collect, the more we can understand about the osteology of this animal, like what did its whole skeleton look like, how is it different or similar to other dinosaurs. That can give us clues as to what it's related to, the evolutionary relationships, clues to its, its anatomy, its behavior, everything else. But also, it can give us an idea of, what kind of individual variation do they have? Are there differences between males and females? Were these social? Kinds of stuff like that. The more specimens we have, the easier it is to answer those questions. So, looking at the quarry here and take a look at some of these other bones. Again, if you're just tuning in, I'll show you how many bones we have here at this site. It is pretty impressive. So, let's see, anything cool and new?
No, we're just cleaning so
Yeah.
we can see if we've got anything cool
Excellent.
in you.
We've already found some really cool things. I'm impressed already. But yeah, got a lovely rig right here. I should have brought my laser pointer in here. Is that just a weird concretion sitting under the...
This guy, yeah, that's a concretion up there.
Yeah.
Gotcha, yeah.
That's just to keep the pipettes from getting dusty.
Nice, smart.
It's not working.
Yeah. Yeah, if there's one thing we have a surfeit of here besides bones, it's dust.
Yeah.
Yeah.
Josh did a quick test on one of the concretions yesterday. Dropped a little acid on it.
Mm-hmm.
And
Did it fizz?
it fizzed like heck. So these seem to be very carbonate rich.
Interesting. Okay.
Which is not unexpected in this depositional environment.
So what does that tell us for everybody watching at home? If it's carbonate rich,
Carbonate rich means you're going to have a lot of... This is a fossilized soil. This is a paleosaur. Often you'll find that kind of a thing in a seasonal environment. Think like I always think coastal Texas is similar to that, but
Okay.
you find it similarly in like, you know, Kenya, places like that.
Yeah,
where you'll get
yeah.
these carbonate nodules that form in the soil during periods of wet, dry, wet, dry.
Right. Okay.
So very likely this, I mean, it's continuing to indicate, besides the overall paleosol, you know, switched between green or kind of purpley red, that Cedar Mountain was definitely pretty seasonal,
Interesting.
which is confirming what we know.
And
So
yeah,
that's
that
good.
could also be a big part of the story here. Well, we'll probably talk about the taphonomy more in depth in a little bit. I might want to save that for later. But
Yeah.
that's what Michael here studies, and starting to figure this out a little bit.
We hope.
It's exciting because, again, it's incredibly weird to have a site here where you've just got dozens, maybe hundreds, maybe 1,000 Gastonia all in the same spot, and it's almost all Gastonia. There's hardly any other critters here. What in the world led to that, you know? How did all these animals get buried in the same place? Especially since we kind of suspect a lot of these armored dinosaurs weren't particularly social animals. Maybe they were, but it's rare to find so many together. And we've got a crazy number of them here. So, like, what in the world happened? Yeah, trying to figure that out. Especially since the bones are all disarticulated, too, for the most part. Like, there's an interesting story here. We can decipher it. So, anyhow, we've got bone here, we've got bone here, here, there's bone throughout there, there's that rib. There's just stuff everywhere. Here was that big spike that Macy found earlier, too. When I put, thank you, Macy. Yeah.
Yeah,
Nice.
there's a nice outline coming out around that.
That's really nice, yeah.
Yeah. Yeah, it's definitely a nice plate.
In fact, let me go grab my laser pointer and I'll be right back. I'll try not to get tripped up on the tripwire here.
Yeah, I'm gonna take that trip wire down.
Okay. And again, if anybody's just tuning in and you appreciate what you're doing here, and you'd like to contribute, you know, even a small donation would help out this museum. It's the Prehistoric Museum out in Price, Utah. We're doing what we can with the resources that we have, and honestly, the more donations that come in and everything, the more we're able to do stuff like this. I like to say that you won't get better bang for your buck if you want to fund science than in paleontology. You know, we do a lot with very few resources, and we're proud of it. So, not a lot of overhead here. Every few bucks that get donated go directly toward this field work and research. It's important stuff. Laser pointer go.
There at the end, but you know, some of these are.
Where did I put that? Oh, here it is.
Yeah, seem to have been
Does it work? Yes. Excellent.
Yeah, sometime before final
Good.
burial. Yeah, because that's just compression.
And Generating Views says, this is just as much fun as watching all those underwater exploration live streams on YouTube. Yeah, get wrecked, marine biology. It's paleontological fieldwork here. Yeah. Yeah, let's jump back in there.
And a little less rocky.
No, it's... What's cool is that, like, paleontology and marine biology actually have a lot of overlap if you're studying oceanic animals. Paleontology is such a broad field. You know, we're talking about the whole history of life on Earth, going back well over 1 billion years.
Sometimes what I'll do.
The way to study that kind of thing is to look at the fossil record. So there's a lot of like paleo marine biology, and yeah. So when I crack jokes like that, it's entirely in jest. Marine biology is a really cool field, and I have no ill will toward anybody who works in that. We're all scientists. We're all in this together, trying to figure out, the mysteries of life on Earth, how it all came to be. Agent Orange, thank you for the gift subs. I really appreciate that. Here, let's get our. Let's get our analog alert going. In honor of those 5 gift subs, Agent Orange. Let's hear from a Gastonia over here. Here. The voice of the ankylosaur. You ready? There you go. Here. One more. Thank you very much for the gift subs, Agent Orange. I appreciate it.
So I might do that next year to deal with some of these concretions that are around the bone.
Like the rock saw goes up here and that's hiding underneath that.
Oh yeah, you'd have to be super cautious about.
Let's see here.
That's cool.
We could do some lasering now.
All right.
We got rib. Actually, if you want to point to some of these things, Michael.
Sure, yeah. Yeah, we got a rib here. That's kind of the most prominent bone you're seeing. There is, you're not going to see it on camera, but there is a bone here that is sitting perfectly vertically.
Shoot.
And is fairly flat. There was a floaty bit on the end of it that was really crumbly that we took off.
Nice.
I'll try to chase it down to the extent that I can. I don't know how much more of it there is. It's either a very flat bone that's sitting against the rib like this, or it is what we call the transverse process of a vertebra.
One of the wings that comes off the sides.
Right, the wings off the side of the vertebra.
Yeah.
Or potentially the neurospine off of vertebra if it's sitting differently. That's sitting, vertically. One of the two. There's a lot of little bits that could be osteoderms. That could be an osteoderm.
Osteoderms are little armor plates. Little or big. These ones are little.
This one here is some kind of limb vertebra. It's got that, I think we talked about it yesterday, that really nice pebble deposit right behind it.
Yeah.
And you can see there's basically there's one pebble there, one there. There might be one there. But almost all of them are located in spots that are sort of these little pack areas of just pebble. So it's kind of interesting relative to the quarry over there. This area here is light on bones, but I suspect as we push into the hill here, we're going to hit a lot more.
We're going to get a lot more dense
as we go.
Interesting. Okay.
Yeah.
Cool. It's a nice hypothesis. I'm excited to test it. Yeah.
We'll have to see what happens as we push inward.
Very cool. Thanks, Michael. Yeah. So again, laser this real quick. That's that other big spike that Macy found earlier. Super impressive looking. And then this, still looking for the edges around this, right? Looks like you've kind of got some edge going here.
Looks like there's an edge right here. There's a couple bones going under here and a little osteoderm right here. But it looks like I have the edge around here and possibly around this side as well. So it might be broken right here a little.
No, you're totally good.
Nice. Could be a big ol' osteoderm.
Yeah.
That or doesn't quite look like a coracoid or a scap or anything.
So
It looks a
it's
bit
probably
large for that, I feel.
Yeah. I think it is probably a big ol' armor plate. Nice.
Yeah.
And then we've got a whole smattering of bones over here.
Oh yeah.
Well,
Just all over the place. Just bone pavement.
I think this is a concretion.
Yeah.
Yeah.
And then
Yeah, that's a concretion. So that can go away. That makes things easier.
Clean up this a little bit here.
Yeah, I'd keep cleaning that up.
Is these bits of bone or completion?
So again, does this need to be left in place?
Wanted to make a bit more room around,
Balance in.
a bit more room around this bit of bone as well.
This is blue.
anything new over there, Erica?
Yeah, come take a look at what Kaylee found.
Let me see if I can scoot in behind you somehow. This is gonna be I can probably come in from the top. Let me do that.
Let me get where you are.
Let's see.
Concretion, though. I can't tell. 5'8" away.
Yeah. You'll be missing
Foot or so.
Llama Monka. That's funny. That was actually that was a popular nickname for Barnum Brown, the guy who discovered T-Rex and a lot of other things.
Yes.
Yeah, they would call him
I think
Mr. Bones.
Yeah.
All right.
I don't know.
If you want to use the laser pointer if you like.
I'm pretty sure that's
Yeah.
going to be a good
So-
osteoderm. So
One right next to each other.
Nice,
And
well
then
done.
Kaylee's
I'd say
working hard
work
on
through
getting
here.
that.
Nicely done.
Yeah, and
Holy
then
cow.
we just
kind of work
removed
this
a
down, see
very
if you
large
can
concretion
get a
from
trench.
here,
Beautiful.
which
Just
really
started
helps her
around
finish
any of
out
this.
cleaning up around these areas and
Nice.
get ready to probably
And
jacket those and
if
pull them out in
not,
one piece.
Uh-huh.
Because
Yeah.
this is
Brilliant.
more
She's doing a great
important
job.
than
Very
probably
nice.
magnesium,
Very nice.
We may just pop some of these
Yeah.
out.
Yeah.
but
Yeah. And then we got this other
first we
rib
try
over
to
here.
do our
Be
due
nice to finally
diligence,
get
try
that
to
thing
work
out, but
around
that's going to
the
require a
bones.
jacket
And if we
probably.
can't,
Unless we want to take it out in pieces.
No, we'll jacket that.
We'll jacket that? Nice.
Yeah, yeah,
I think
and then
that's
this is
probably
going to have to
ribbed,
come
so,
out as soon as
you
we
know,
finish mapping.
Yeah. Do you want to pick up one of those big chunks and
Yeah,
show us?
sure.
Yeah.
It's,
Yeah,
I mean, this is quite
I wouldn't worry
large.
about
That's
that.
huge.
It
Yeah.
is, and it's
Especially
thick.
since
And it's only part of
that.
Correct.
Nice break right there.
Yeah, so these were probably together.
Uh-huh.
I do not know what part of the animal this is from, but
It
it's
looks
very.
like an osteoderm.
It looks like, yeah, really
But
thick.
which one? Yeah.
Like, I don't know, maybe it's like this.
Could be.
This,
Yeah.
and
So something, one of the bigger,
Yeah.
uh,
before you get that off, you
pointier.
gotta deal with this.
ones.
And
But
that-
yeah, it's
Is that a little?
that's next on the list to
Yeah.
Yeah, that's an
get it out of here.
That'd
And
be
then,
really nice
that
not to have
should
to
be
worry
a
about that anymore.
and then this
Should that be
area
able to
right
pop
down
out?
here, which
I
did you
think it
show
will.
everybody the
And
little
if you wanna work on
phalanx,
that,
the
because
Yeah,
toe
but let
bone?
me show it again because
Yeah.
that is really
Just
cool.
kinda
It's so
around it.
cool.
It's
And
lovely.
then
Yeah, so
once
this
you
is
don't
a phalanx, a toe bone. So the plural is phalanges, if you're familiar with that term, Chad. But this is the articular end right here. So this might be where the ungule is, if this is the distal one. So that's where like the claw or hoof would be, right here. And see it, it would kind of, it's got that round surface that it can flex up and
It's
down
like,
on.
all right,
Yeah.
gotta do that
The
for
end,
that,
this part is broken off right here, but it's fairly complete. Yeah, I don't know if that's ankylosaur. I wonder if Susie would have an opinion on that, whether it's ankylosaur or ornithopod.
Yeah, maybe we should show it to Susie.
Yeah.
That's the one that it's definitely not thorough.
Oh yeah, that one. Yeah, we could show that, Susie.
Let's go do
Go for it.
that. Yeah, awesome.
Bring that back to me.
Yeah, we'll do. Yeah, I know
I
exactly
would
where it
bet on.
Yeah.
Wow.
Okay. Yeah, because it doesn't have the whole like ginglymoid thing like you get in theropods. It's got these big depressions on either side of
Yeah,
the disc
yeah.
bone.
This one
Yeah.
should be okay.
Yeah, Susie and Richard would be good.
Awesome. Yeah.
Yeah.
Cool.
Because I know it's not Gastonia. It's too long.
Oh, it's not Gastonia. Okay.
No.
Yeah.
I don't think. Yeah, it's too long.
Uh-huh.
Pretty sure.
Cool. We'll go
Because
ask
yeah,
our...
most of the phalanges are pretty short and squat.
Uh-huh. Gotcha.
And that's a phalanx. So.
Yeah. Yeah. Cool. We'll go ask our ornithischian experts. Let's go do that right now. Here we go. And we got to make sure we put this back because where each of these fossils comes from that's really important data to record. You know, that's the difference between an actual scientific excavation and just treasure hunting. We're taking very, very careful notes. Drawing maps, taking really good data on where each of these fossils come from, because the provenance is just about as important as the fossils themselves. That data, without those data, these fossils might as well be paperweights. All right, let's see. Where did Susie go? Let's see. Oh, well, we'll see when she returns, and we'll ask her about it. Yeah. And there must be thousands of bones? Absolutely, Lama Monka, yeah. There literally are thousands that have already been collected over the years. This is not a new site. So, Lowry site, as it's called here, this has been worked by multiple institutions at this point. The Denver Museum of Nature and Science opened this up back in the 90s. And Josh's museum, the Prehistoric Museum in Price, Utah, they've been working here since 2023, so this is the third year of excavating here after they reopened the site. And there are, literally thousands of bones in the museum in Denver, Colorado, and now in the museum in Price, Utah as well. And the cool thing about taking as many notes as we get, about recording as much data as we do, is that we'll have an actual number on how many specimens we have.
They give names to all these
So,
different
really cool.
osteoderms, and if it's below X number of centimeters, I think
And
2 centimeters or something like that, it's considered an osteoderm.
Daily Daspas, can you show us the Ruby Ranch if you can? Yeah, it's right there. There's not much to see, but that kind of grayish layer up there is the Ruby Ranch. In fact, I think there's a number of different colors. You've got a lot of different colors. I think this is all Ruby Ranch until you get to the Natarita, which is the sandstone cap at the top. Everything below that is Ruby Ranch there on that hill, as I understand it. Yeah. And is it Mesozoic? Absolutely, Claire, yeah. So that's also part of the Cedar Mountain Formation. It's the Ruby Ranch member of the Cedar Mountain. We're down here in the Poison Strip member of the Cedar Mountain. And that was, that actually had something to do with that body t-shirt design that I couldn't show you for the sake of keeping this a family-friendly broadcast. But Alyssa and Jeff came up with an interesting design put on t-shirts about the Poison Strip. You can use your imagination. But it involves an ankylosaur doing a certain kind of exotic performance.
That was a very diplomatic
But,
way
yeah.
to describe that, Danny.
What's that?
That was a very diplomatic way to describe that.
I appreciate it.
True professional over here.
I've had a lot of practice making things family friendly. But yeah, and are there real rubies in there? No. So it's called the Ruby Ranch member because it's named after a place called Ruby Ranch. And I think it was, some of the rocks there were kind of reddish. People thought they were ruby colored. That's the thing you'll learn about geology, is that oftentimes
Feel it in 20 minutes.
we tend to be a little bit generous in the way that we describe different colors. So we might go, look at how blue those rocks are. You might say that as a geoscientist, but other people looking at those rocks will go, "What are you talking? That's not blue. What do you mean? That's gray." We've got lots and lots of different color names for different shades of gray, essentially. And that's something that I have to constantly remember when I'm talking to non-specialists, is that they might not have the eyes for that kind of thing. Yeah. Oh, and Susie and Richard, actually, wanted to see if you might have an opinion on this. We don't think this is Gastonia. We've got a little phalanx here.
Yeah.
Does that look like Iguanodontian, maybe? It doesn't really look theropod.
Doesn't really look theropod, does it?
No.
Hasn't got the deep pits on the side. Yeah, I agree.
Yeah. Yeah?
Yeah.
It's one of our few
Yeah, seems
non-Gastonia elements so far. Yeah.
Oh, nice.
Yeah. Yeah.
So where is that from?
From right over here.
Oh, cool.
Yeah. We found that the other day. Pretty high up.
Can you just get them to find the rest of it?
I wish. Yeah. But yeah, I wonder if that's something like Planocoxa or like Iguanodont that we have. I think it's from the Poison Strip.
Yeah.
Yeah.
There's a lot from the Cedar Mountain in general, aren't there?
Oh, yeah,
They're well known,
certainly.
very diverse. Yeah.
Yeah. So we've got one, maybe two new species we were digging up in Doling's Bowl last month.
Oh, yeah?
We've been working that for like 3 years at this point, 4 years.
Our rocks
So-
in the UK that are a similar age to this, to the Cedar
Yeah,
Mountain,
yeah.
the Wilding group, we're finding increasing diversity of Iguanodontians.
is
We're
nuts,
describing new ones all the time. So
Yeah, yeah.
We have a new one we're doing right now as well, so yeah.
Very nice.
Yeah.
Yeah.
Gastonia?
Yeah, we just covered Felipe
That's
Bertozzo's new Iguanodont
Oh, yeah.
from Portugal the
yeah,
other
yeah,
day.
yeah,
I did an
yeah.
interview with him on
Carry,
stream.
if it
carry,
ended right
carry
there.
something.
Cariocecus.
Cariocecus, yeah.
Yeah, yeah.
So much shorter.
It's a cool
than
critter.
that.
Yeah.
Yeah.
Yeah, could be an F1. Sure.
Very cool. Yeah. Is it okay if I introduce you to the chat, Richard?
absolutely.
Yeah. So this is Dr. Richard Butler right here. You're a professor at Birmingham, right?
I am, yes, yeah.
Yeah, yeah. It's wonderful to have you out here.
Great to be out here.
Yeah, we've also shown videos on stream of you, I think, at that sauropod track.
Yes, absolutely.
Yeah, yeah. And a number of other things, too. So it's great to have you here in person.
Well, it's
Yeah.
excellent. Yeah, so we're out in Utah.
Nice. Yeah.
Been here for the last couple of years, and it's just an amazing place.
It really
Amazing place
is.
to bring our
We're
students.
really lucky to be here for sure. Yeah. Cool. Yeah. Thanks, Richard. Yeah. So cool. Yeah. All the stars are here in chat. But yeah, yeah, yeah. New species. That's not uncommon. Daily Dasp. Again, I presented on this at SVP last year. The rate of dinosaur discovery. Yeah, I found that over the last decade, there's a new genus or species of dinosaur described in the literature every 9.58 days. So it's nearly one every week. On average, between 35 and, well, it's like 35.5 new dinosaurs every year. That's a lot. That's a lot. And that, I've been really interested to see the up until COVID hit, and then it went way down. And it's starting to come up again. Currently in 2025, we're on track to possibly have a new record. If the current rate continues, we will have more than 47 new dinosaurs published just this year in 2025. So it'll be interesting to see whether that happens. That's the current projection. We'll see if that holds. Yeah. Yeah. And Heritage Nomad says that's still slow compared to what's out there. It is. Yeah. That's the thing, is that if we had more, I say we, when I say we, in this case I mean paleontologists in general. If we had more resources, we had more funding, if we had better facilities and stuff like that, we could double that rate easily, I think. So much like our limiting factor here is not the number of dinosaurs. The limiting factor, money, you know. This kind of field work that we're doing here, this crew is out here for 3 weeks. I'm out here for 2 of those weeks. And that's about the limit of what they can do with funding and other resources. So, but you could have a crew here working this site year-round for probably a century. And they still wouldn't find all of the bones that are just here in this hill. This is about 8,000 square meters of ankylosaur bone bed here. And again, it's a bit of an extrapolation. But the thing is, we've got one pit here, one pit there. There's like 30 other pits that Ken Carpenter and his crew dug back when the Denver Museum was working here. And everywhere they dig in on this hill, they find ankylosaur bones. So we think the whole thing is just full of ankylosaur. It's just full of Gastonia everywhere. It's extraordinary. It really is. So yeah, like what's going on here? What's the story? Why did all these dinosaurs get buried in the same place? That's what we're trying to figure out. And the more specimens we find, and the more we study this, the more the pieces start to come together. So we've got a hunch now. I say we, it's mostly Michael, who's working on the taphonomy of this site. We've got a hunch as to what's going on here, but at this point, it's just a story, you know? We have something that sounds plausible, but we're trying to test it with more and more evidence. Yeah. And Geeks Tour says his oh boy, are they, yes. Previous teams tried possible heavyweight when it came to this field. If they are they publishing much? Absolutely. That's another project that I've been working on off and on, is how many different dinosaurs have been named, different genera and species of dinosaur, have been named from each country in the world. The U.S., according to everything that the data that I have so far, the U.S. is in first place. China seems to be in second. They might pass us up. Not to cast aspersions on the country I grew up in, the U.S., but doing paleontology is difficult here in the States. There's not a lot of funding, and scientific enterprise in the U.S. is being cut left and right at a federal level right now. The current presidential administration, they're kind of doing their best to just gut science in the U.S. Like, they really do not appreciate scientific research. It's very clear. I am mincing words right now. Like, I could be a lot more forceful, but this is a family-friendly broadcast, and I'm going to hold my tongue. But it's not good in the U.S. Right now. China's doing the opposite. They are funding science left and right. They are encouraging kids to go into science, technology, engineering, math, arts, and humanities. They're really forging ahead with this kind of thing, and they're starting to leave the U.S. behind in the dust. We're seeing this in paleontology right now, where in the U.S. people are losing their jobs, programs are being cut, grants are being pulled. American science in many places is withering on the vine. In China, it's thriving. And they're opening new fossil museums left and right. Like, Jim Kirkland likes to talk about this. They have so many different sites in China that are like Dinosaur National Monument times 10. And sometimes they're building museums on site and turning these places into fossil parks where, not only are they funding the science, but they're also, building these really beautiful displays with all kinds of great information where they're educating the public with them and they're inspiring young people to go into science. I sorely wish that we in the US were able to do the same thing, but right now we're in an environment, we're in a time that US science is being actively suppressed. So, yeah, again, that's a big part of why I do these live streams. This stuff is important and I want to show it to people. And, you know, if this site were in China, they would have already built a museum here. You know, there would already be like a huge structure built over this site so that it could be worked year round. Yeah, I wish we had that here in the States, you know. But yeah. Anyhow. And Geeks Tour says, are U.S. scientists welcome in China? Are U.S. scientists going there if they are welcome? In a lot of cases, yeah. So I've got friends and colleagues who I went to school with at Montana State, and some of them, people like Alida Bayul, she is thriving over there in China. She's originally from Tahiti, then I think she lived in France for a while, and then she came to the U.S. for grad school. I was out in the field with her in 2011 when we were digging up the Yoshi's Triceratops specimen. And yeah, she I think she got her PhD in Montana. She's now in Beijing working at the IVPP, the Vertebrate Paleontology and Paleoanthropology Museum in Beijing, and she's doing quite well over there. She's doing really cool stuff, and she's very well supported. Oh, yeah. Anywho, yeah. And, oh, thank you, Daily Dasp. I appreciate that. Yeah. In relation to Oksana? I don't know who that is, Claire. That joke went over my head. Yeah. But yeah. And yeah, that is a big deal. There is a huge brain drain from the U.S. at this point, where like the European Union is trying to hire American scientists. They're being like, hey, you know, your lab is being shut down, your funding is being cut, come to Europe. We'll fund you. Set up your lab here. Contribute to our economic success, contribute to our economy and culture and everything else, and people are doing it. I know there are a good number of scientists who are leaving the U.S. right now for greener pastures, and this is going to have generations, you know. I'm staying here for the time being. This is where I live. This is the place that I love. I was born and raised here in the U.S., and I love this country, but its current leadership is doing their darndest to destroy science here, and it's not good. I'm going to stay and fight for as long as I can. And science streams, there you go, yeah. Balint, who is another research scientist who also streams here on Twitch. Go follow Science Streams if you're not yet doing so. Balint and Lita are a married couple of research scientists, molecular and systems biologists, geneticists. They do really, really cool science content. You should check them out. But Science Stream says every dollar that NIH funds, National Institutes of Health, the return on investment is $2.65. Yeah, it's a huge economic engine. If you fund science in a place, you see a huge return on that investment. It makes me think that the people who are cutting science here in the U.S. right now, people who are in charge of the federal government right now, this current presidential administration, they don't care about that. They don't care about economic growth. If they did, they wouldn't be cutting science. Anyway, I don't want this to get too political. I'm going to get some water. We're going to go walk around the quarry a little bit more, check out some other things. Yeah. But yeah. And Science Stream says, thank you, Danny. I had to have this number on hand because I've been meeting with political offices this week to advocate for science funding. Very cool, Science Streams. Well, that's awesome. Shoot, I wish you the best of luck. It's so important. If you're interested in this kind of thing, I'll recommend a book to you real quick, too. I just started reading it recently. It just came out. I got the audiobook so I could listen to it on the drive over here. But it's called Science Under Siege by Michael E. Mann and what's the other author's name? Is a climate scientist and an epidemiologist, I believe. Thank you, Claire. I appreciate you putting together that command. Peter Hotez. There you go. And good stuff. Thank you, Claire. Yeah. Again, if you're concerned about this, if you want to learn more, it's a good place to start. Let's get some water. We'll check the current temperature too, just for curiosity's sake. Let's see here. Got our temperature and humidity meter. 91, oh, 90, okay. And 20% humidity. 89. Feels hotter than it is, I guess. 88. We're getting a bit of a breeze. 87. Oh, that breeze feels nice. Yeah. It's a lot cooler under the shade tarps there. Oh, Iacane, how are you doing? Hello. Iacane says, my old medical team just laid off 15% of their staff after losing NIH funding. As a result of current affairs, I've seen multiple promising treatment studies abandoned due to lack of funding. It's bad right now. It's only getting worse. It's dire, you know. It's not good. When you have promising medical developments, treatments, new medicines, things like that have to be abandoned because of lack of funding. Sometimes after the majority of the work has already been done, they're like near the finish line, and then their funding gets cut. It's almost like all that money up until that point gets wasted. It's bad. It's really bad. And let's see here. What I was going to say too is that I don't know. When we're talking about science funding and we're talking about medical breakthroughs and stuff like that, you might wonder, well, why are we talking about this on a paleontology channel? You know, what does this have to do with fossil science? It's actually quite a bit, I think, in one particular sense. And it's that this kind of science that we're doing right now, when we're out here digging up dinosaurs, this is the sort of thing that inspires people to get into science in the first place. I've said this before, I'm going to repeat it again, so apologies to everybody who's heard this spiel before. But I really want to be able to do a study, maybe team up with a sociologist or somebody like that, and do a representative survey of people in different knowledge fields. Not just science, but medicine, engineering, technology, philosophy, law, you know, stuff like that, history, library sciences, all of it. And for all these people who, you know, the pursuit of knowledge is their job, I want to ask them, how many of you first fell in love with learning dinosaurs or paleontology in general? How many of you first to love learning because of extinct critters like this, because you were inspired? For so many kids, especially here in the US, and I think all around the world, dinosaurs are like a gateway into the sciences. Because here's these animals that lived tens of millions of years ago. The only reason that we know they even existed is because of, you know, really difficult scientific work. It's not like you can go to the zoo and see a stegosaurus or something like that. It's not like you can fly out to, you know, Africa and see a brachiosaur walking around. The only reason we know that these critters ever walked the earth is because we have people out in the field digging them up in the first place, studying them, publishing on them, Dinosaurs are kind of a quintessential scientific creature in that regard. It's only because of science that we even know they existed at all. And I think that's a wonderful introduction to science for kids, because dinosaurs are really compelling, they're really interesting animals, and they just capture the imagination of people, especially kids. And for a really precocious child in particular, like, are a way to kind of explore that idea of somewhat arcane knowledge. Since you can't just go out and see them, you read about them in books, you see them in museums, stuff like that. It requires there's a lot of concepts that you have to understand to like really appreciate dinosaurs. And it's often something that kids' parents don't know anything about. So if you're a kid who's really into dinosaurs, not only are you using them to learn how to read, you're learning how to process information, how to get excited about, abstract concepts like deep time, evolution, biogeography, things like that. But also, your parents don't know anything about this, most likely. And so you're learning how cool it is to know about something that the grown-ups in your life don't have any clue about. And that's a really powerful feeling for a lot of kids. I think it's, for a lot of people who grow up to be paleontologists, that's how they got started. It is kind of an intoxicating feeling to be like, yeah, I know this thing that none of the grown-ups in my life know about. And it's something that's real and legitimate. It's not something like, I don't mean to badmouth it, but it's not something like Pokemon or something like that. Your parents don't know anything about it, but, well, it's a thing that's intellectual property. Dinosaurs were real. They actually roamed the earth. There's like a real authenticity and power in that. And to be a kid and get really interested in that, that's a powerful feeling, And certainly not everybody who had an interest in dinosaurs in childhood grows up to be a paleontologist. Certainly not the case. Very few of us, actually have it. Terminal cases of dinomania are few and far between. I'm one of them. A lot of the people here are too. So many people who had that early obsession with dinosaurs, they went on to learn about other things later on. But dinosaurs might have been their first real introduction to the idea of learning. I bet if I were to do this survey and reach out to scientists, philosophers, historians, lawyers, librarians and engineers and people like that, I bet you a significant portion of them first fell in love with learning because of dinosaurs. And I think it'd be really cool to have numbers on that, to be able to point to it and go, look, here's the percentage of people who said, oh yeah, dinosaurs are the first thing that I remember learning about as a kid, the first thing that, that's how I learned how to read, that's how I learned how to get excited about ideas. I think that has a tremendous influence on our culture, and I think that's where fossil science is really important, not just for giving us perspective about the past, not just for telling us what the history of life on Earth is, but also inspiring people to get involved with learning, with knowledge. I really want to do that, to do that kind of a study, because I feel like it would help demonstrate how important this field is and how important it is to fund it, Because right now we're severely underfunded as an entire discipline. Paleontology is... I've been on field crews where we've been out for like 2 months, digging up scads of dinosaurs, and our overall budget was like $900 for the whole summer. And we just have to make do with that, So yeah. Nith says that would be a powerful metric when seeking funding. I hope so, yeah. DeRozan says paleontology to a kid is about learning the unknown. It's exciting. It can really carry over in life. Absolutely. Yeah. Yeah. When I think about it, you might be right. Never seen it like this, says Killer Dave. Yeah. I thought about that once because I heard somebody say, well, paleontology is cool, but it'll never cure cancer or anything like that. But you know what? It might. If there ever is a cure for cancer discovered, it might very well be from somebody who first fell in love with learning because of dinosaurs at a young age, So this kind of work that we're doing out here in the field, I like to think that it has important benefits to society as a whole, you know? Yeah. And there you go, Iacane. It's extremely difficult to build and create and discover and develop. It's fragile and vulnerable and unendingly loved. That's beautiful, Iacane. Yeah. Tearing up over here. Yeah. And that's really cool, Daily Dasp. Yeah. And Geeks Tour says kids are sponges. When they find an interest in something, if they're allowed, they're all in. It's really cool, just like that enthusiasm. And I feel like the way our society is organized, it's almost like it's built to like just beat that curiosity out of people, to make them jaded. And that's why I think this stuff is so important. Darius, he says, if I ever win the lottery, I'll be dumping as much money as I can into paleontology and archaeology work. I appreciate that. Here, let's take another stroll around the quarry here. Yeah. Anyhow. Oh, again, to anybody who's just joining us, welcome to Paleontologizing. My name is Danny Anduza, and out here in the field in the early Cretaceous Cedar Mountain Formation, we're digging in rocks about 130 million years old, and all these fossils are going to the, USU Eastern, so Utah State University Eastern Price Campus, Price, Utah, Prehistoric Museum. It's a long name. We'll just say the Prehistoric Museum. It's where all these fossils are headed. Will they be held in perpetuity in the museum, to be studied by researchers, enjoyed by the public, all of that. We're digging here on public land, on Bureau of Land Management land, so these fossils belong to we the people, and thus they belong in a museum. And yeah, we've got a whole crew of students from the UK, from the University of Birmingham, who are visiting us right now for the next couple days, and they're helping on a bunch of these fossils, and they're starting their careers as paleontologists, and it's wonderful to be part of this, you know? Like, this is a new generation of fossil scientists here who've joined us, and it's, again, an honor to be part of this whole thing.
It's really fun, actually.
Popping in again. Anything new and exciting emerging?
Lots of osteoderms.
Lots of
Mostly
osteoderms.
from over there.
Beautiful. Okay, nice. Cool. Again, if anybody's just popping in, we're digging up this kind of dinosaur right here. I say we. I'm walking around yapping, talking to the camera, but yeah, this is Gastonia right here. It's an armored dinosaur from the early Cretaceous. One of the spikiest dinosaurs that's ever lived, we think. And we've got a huge number of them here at this site. Bones are everywhere.
Got a huge pile.
Shoot, look at that.
Yeah. Isn't that amazing?
It's just like a giant hairball of ankylosaur bones. That's nuts. Wow. Like, how do you even... You see the challenge here now. It's like, how do you even dig around? Yeah, it's a good problem to have, but it is a problem. There's just too many bones at this site. Really impressive. Yeah. And that's a pretty cool looking one there. Neat.
This one?
Yeah, I know that was there before, but you've got it nice and clean there.
I think it is supposed to be like an... Is it ischium or ilium?
That's going to be an ischium diagram here. So, the ilium are the hip bones at the top, right here. And then you've got the... I don't know where the pubis is. It might be hiding behind the ilium here. And there's the ischium along the back. These guys have got such weird hips. And they're so broad. Just like a barrel-shaped dinosaur. But yeah, so I think that's what that is right there.
Osteoderm there as well.
Very nice. And one of those armor plates. So you can see there's just a zillion armor plates on these guys. Really neat.
I assume this is a bit of a limb bone.
Mm-hmm. We were thinking that's probably a tibia, but
yeah.
I immediately thought humerus, because it looks kind of like a duck-billed dinosaur humerus, but no, these guys have got a very different looking humerus. That's the upper arm bone here, but we think, no, it's probably one of these, the main shin bone, the tibia right there. Yeah.
There's a vert as well.
Very nice. Yeah. Shoot. This is awesome. There aren't many dinosaur sites like this in the UK, so
No.
I'm glad all you folks are here. This is really cool. Awesome. Nice work.
Thanks.
Yeah, awesome. Let's see. I heard we had more osteoderms over here too. On this side?
Little baby one.
Oh, very nice. Beautiful. Some blue on there. Lovely. Yeah. 130 million year
You
old
can see into the side of it as well.
dinosaur armor plate. Yeah, look at that interior texture. Very nice. Thanks. Cool hat, by the way.
Thank you.
That's nifty. Yeah. Cool stuff. Anything new over there, Erica?
Flat.
Uh-huh.
It's going into the hillside.
Okay. Here, I'll
So-
put your pointer and not get you in the eyes right there. Yeah. Nice.
There's a little piece right underneath it that's got like a tiny little bone.
Oh, wild.
Really tiny.
Does it
and
look like ossified tendon? I can't really see
It
from
looks
this distance.
it looks tendony.
Nice, yeah.
Yeah, it's got the striations on it.
Cool.
So I'm trying to just keep that in place.
Really neat.
Yeah.
Awesome. Yeah, and shoot, for anybody in the chat who's not familiar with the concept of ossified tendon, that's a cool thing that dinosaurs do, where it is what it sounds like. It's tendon, which is normally soft tissue, but it's ossified, it's turned to bone over the course of the animal's lifetime. So it starts off as soft tissue, and as the animal grows and develops and matures, it turns to bone. So ossified tendon, we've got it in a whole bunch of different ornithischian dinosaurs, the beaky plant-eating dinosaurs. And I think we might have it, I know people say we have it in theropods, but it might not be homologous. In fact, I kind of want to go talk to Susie about that. Yeah, maybe we'll do that. But it's dinosaurs use in order to stiffen certain parts of their scalp. So it's, I think, always along the vertebral column. So you get big tendons in there that, again, like I said, they turn to bone as the animal grows and matures. And that it has certain advantages to stiffen the spine like that if you're trying to hold up the front part of your body, if you're just trying to, I don't know, support your weight. Ossifying your tendons like that is something that a lot of ornithischian dinosaurs do, and yeah, it's pretty common. It seems to be a pretty successful strategy. Like, whatever they're using it for, it seems to be working. Yeah. But yeah. There you go. Okay. Yeah. Oh, and somebody was asking, do we know the origin of the name Gastonia? I do. So it is named after Rob Gaston, who is, you can see his website at gastondesigns.com. But Rob Gaston, he works over there in Fruita, Colorado, just over the Utah-Colorado border. We did a tour of his workshop last summer, which was really cool. That was one of my favorite streams we've done in a long time. But Rob Gaston helped discover the site originally that Gastonia came from, and Jim Kirkland named it after him. In 1998, I think, that paper was published. Gastonia burgei. So it's actually named after two different people. It's named after Robert Gaston, and it's named after Don Burge. And maybe we'll ask Josh over here who Don Burge was, because he's got a connection to that name. Yeah. This is talking to the chat about where the name Gastonia comes from. Gastonia after Rob Gaston, and burgei after...
Yeah, Don Burge, who was the founder and first director of our museum.
Nice, so kind of your predecessor.
Yeah, so he was the first curator of paleontology and director, and then there were two more after that, and then me. So,
nice, yeah.
So yeah, I'm number 4 on the list.
Yeah.
In the 60-year history. He was director and paleo person for about the first 40 years.
Shoot.
Of the museums.
And
I think he retired the museum started in 61, and I think he retired in 2001 or 2002.
Oh, wow. Shoot.
Because then Reese Barrett came on in 2003.
And And Don Burge actually helped establish the museum in the first place, right?
right.
So it's kind of the driving force
It was
behind why that museum exists.
Yeah, I mean, he was a geology professor on the, at that time, Carbon College campus that then became the College of Eastern Utah and is now Utah State University Eastern.
Gotcha.
And so yeah, he was teaching geology and he loved rocks and Native American artifacts. And so he said, you know, a lot of people are going out collecting this stuff. This was before a lot of the laws were in place, or at least enforced. And he said, why don't we, you know, bring together all my rock hounding buddies and make a museum?
Nice.
And that's what happened.
That's why we're here today, in a sense. That's the institution that we're excavating for. So all of these fossils that we're finding here will end up in the permanent collections of the museum in Price, Utah.
They will be living in Price forever.
Right. Yeah. For as long as there is, I don't know,
civilization.
Civilization. There. Yeah.
As long as we
after
have
we're dead.
museums in America.
But anyway, that's the whole point, you know. As a that belongs in a museum. That's what we're doing here, you know.
Yeah, and that's the big thing, you know. We do this not just for the research that we're gonna do on these fossils. This is for, you know, putting new material on exhibit, having specimens for other researchers from around the world to come and examine. So yeah, it's just not just for us, but these fossils belong to everybody, belong to all U.S. citizens, and from a scientific standpoint, belong to everyone in the world. So they're hopefully a lot of folks will come from all over the place.
And people already do. I mean, it's kind of nuts. We looked it up the other day. There's like 8,000 people who live in Price, Utah. It's not a large town. People visit from all over the world to come study the fossils there. And you've got how many holotype specimens?
Let's see, 8. Yeah.
Oh, I thought it was, okay. Well, that's still impressive.
Let's see. Utah raptor, Gastonia, Fluoropodes, Animatar, Cedar pelta, Ned Colbertia.
Those are just dinosaurs, though.
Those are just dinosaurs.
So,
and then,
8 dinosaur holotypes.
Yeah, and then a holotype trace, Pustula ichnus, which is basically the algal matte texture that preserves Mill Canyon dinosaur track site.
Yeah, out near Moab,
we've got a few holotypes that are still to be named. There's a species of oyster, of all things, that Jim Kirkland is supposed to be naming.
Nice,
and then, a few other things as well. I've got a couple of dinosaurs that are still to be named. There's a little tiny croc from the Jurassic that doesn't really fit with anything that's already named. I call it the Chihuahua croc because it's about the size of a Chihuahua.
Is it terrestrial?
Yeah, terrestrial, fully terrestrial croc.
Do you hear that, Alexander Morris? We've got a real croc fanatic in the chat.
Oh, cool. Yeah, this is. Yeah, somebody asked me the other day what my favorite croc was, and I said alligator because it's the one I've eaten. But
that's fun because they can eat you too. You know?
I'd probably say this unnamed croc is because it's probably gonna be the first croc I work on.
That's awesome.
It's neat. It came from just outside the Cleveland Lloyd Dinosaur Quarry.
Oh, interesting. Okay.
Yeah. So I think within a football field of the quarry itself.
Is it related to that little tiny croc that came out of that borehole at Dinosaur National Monument? You know that story, right?
Maybe not.
Okay, yeah. I forget what it's called, but it's a tiny little terrestrial croc. I don't remember the name.
So there's a group called Atoposaurids that not a ton of folks have worked on, at least in recent years. And that's what this one has been ID'd as.
But it turns out it's different.
I haven't confirmed that for sure. I mean, it's a clade of crocs.
Oh, okay. So, sorry, I was thinking you're talking about that genus.
Yeah.
Never mind.
There is a genus Atoposaurus, but that group of crocs, this could be an example of that. Just based on size. Most of them are from, at least in the Jurassic, are from Europe. There's one denary fragment from Wyoming that's named. John Foster named a few years ago.
Oh, nice.
But otherwise, nothing from the Jurassic of North America that's named. So we'll see what this is. This doesn't line up. I was working with somebody who knows a little bit more about crocs when he was visiting the museum, and kind of working through the list of named crocs from Morrison, and doesn't really line up with anything. So
Interesting.
yeah, it could be fun.
Very exciting.
Yeah.
Yeah. Cool stuff.
Stay tuned.
Yeah. Thanks, Josh.
Try to do some work on that with a student soon.
And then let's see if I can bug Richard and Susie for a second. I wanted to ask, we were looking at some ossified tendon over there.
Oh yeah.
And so maybe you could just talk for a minute about ossified tendon and why it's important to ornithischian dinosaurs in particular. Yeah.
Well, it's,
Let me think for a minute. See what Susie says first.
Yeah.
And I'll come in off the back of that.
Awesome, yeah. And thank you for letting me put you on the spot like this, too. I appreciate it. Yeah.
so ossified tendons are really widespread across ornithischian dinosaurs, and they strengthen the spine. So they are, obviously we have tendons that attach our muscles to our bones. I got that the right way around, I think. And sometimes they ossify, so sometimes they turn to bone. And we see this in turkeys, for example, today.
Okay,
So if you have a Christmas turkey or something, you can sometimes get these tiny, very thin, like rod-like bits in them, and they're
realize
ossified
turkeys got
tendons.
that. Yeah, okay.
Apparently so.
Yeah.
I'm not a bird person, but apparently,
I'm a
they're-
vegetarian, so don't ask me.
well, there you go. It's all overburden to me, so yeah. But so they're probably being used to strengthen the backbone. And what we see, particularly in things like hadrosaurs and also iguanodontian dinosaurs, is that they develop this kind of lattice work. It's like a network of ossified tendons all the way down the spines.
Yeah.
And I think this is probably related to them becoming four-legged. So of course, somewhere along the ornithopod lineage to hadrosaurs, four-leggedness evolved, and maybe multiple times. But they probably then needed to kind of have extra support, like a bit like a suspension bridge, to support kind of their back from sagging or something like that. So they probably ossified them as a strengthening mechanism, and weight bearing. It particularly, I think, is a thing that you see with like larger sized ornithischians as well. So
I think one of the really strange things, though, is that this is basically something you see in all ornithischian dinosaurs. Right? So even in the earliest ornithischian dinosaurs, you have some of these ossified tendons.
Okay.
But fundamentally, they don't look like they were moving any different. Really,
No,
from
no,
the
no,
Right,
no,
yeah.
theropod dinosaurs, right? So why they start to ossify these tendons? You don't see that in other groups of early dinosaurs.
It's bizarre, yeah. And what I wonder, too, is that, we see ossified tendons in theropod dinosaurs, like in dromaeosaurs and things like that.
okay, right, yeah.
Is that homologous? Is it the same structure, or do we just call them both ossified tendons, even if they've got different origins or something?
Well, I mean, the tendons would have been homologous to
Yeah.
each other. The fact that they ossify, they probably did that independently, I guess.
Okay.
And it's probably, again, I don't know about development,
Evo Devo,
but it's probably something that's relatively easy to do. So, we see kind of precursors to bones. We can see cartilage turning to bone through ontogeny as things grow up.
Yeah.
So we see kind of the ends of the limbs becoming more ossified over time. We see sutures closing, becoming more ossified over time. So, maybe there's some genetic patterns with it as well.
Interesting.
But maybe there are just tissues that kind of repeatedly through evolution are just easy to ossify.
That would make a lot of sense, yeah. But also, one thing that I've wondered about is, why don't we really see this in sauropods? Because I don't think we do, it's bizarre.
Well, and they're big and four-legged, so maybe we should chuck my theory out the water. Let's start again with that.
And again,
I don't know,
the very early sauropodomorphs would have looked very similar to early ornithischians.
You would think so, right?
But you have it in ornithischians, those earliest ornithischians have it, you don't have it in those. So, I don't know. I guess we don't have a good understanding of why.
And in a way, that's really exciting. Like, this is something that it could be a PhD project or something like that. Like, if somebody were able to figure this out. There's so much that we still don't know about basic dinosaur biology, and that's, I don't know, it's not something to despair about. I think it's something to be excited about. There's still cool things out there yet to be discovered.
Absolutely.
Yeah, anyway, thanks for letting me interrupt. I appreciate it. Yeah. Really cool. And again, it's awesome to have these folks in the quarry. I don't know, it's starstruck is maybe not the right word, but it's something close to that. People whose publications I've read many, many times, and now they're here. That's so cool. And King Seeley, hello. Hey Danny, it's Jake from the Dig. I made it all the way home safe and sound. That's really good to hear.
Yay!
Yeah, we're really happy. Jake was having some tire trouble in the field, so we're really glad that he's made it back home.
It's the best news.
Awesome. That's really, really good to hear.
Love it.
Yeah. Fantastic. It's good to see you, Jake. Yeah, and welcome to the chat. So Jake was here with us for the past, 4 or 5 days, digging in the quarry, and this was his first ever paleontological excavation. And he learned a lot, and we're excited to hopefully have him out here next year. Again, he's doing the thing, going from somebody who is, just had an interest in dinosaurs to actually contributing to paleontological science in a real material way. That's pretty cool. And that can be you too, everybody in chat. I mean, it's doable. It really is. Yeah, it's great to see you, Jake. And thank you, Murph, for gifting Jake a sub there. I appreciate that. Thank you for your generosity. You won't have to watch any ads for the whole rest of the time we're out here in the field, Jake. That's awesome. Thank you, Murph. Appreciate that. Yeah. Yeah. But yeah. Anywho, I hope I wasn't putting Richard and Susie on the spot too much with the whole ossified tendon question, but I don't know, it's cool to think about. Again, there's like basic aspects of dinosaur paleobiology that they're still pretty hazy. With as much as we've learned about these animals, there's still stuff that I guess it's not every low-hanging fruit has been picked yet. And yet there's a whole tree full of fruit. There's so many different research questions that we can ask and potentially answer through the fossil record. Yeah, it's like Jim Kirkland says, these are the good old days. This is currently the golden age of dinosaur paleontology. Even with as little funding as we have, the rate of discovery and the number of people who are working in this field is more than it's ever been. And we'll get through this rough patch right now in terms of funding and these attacks on science in the U.S. right now. We'll make it through with the help of some kind and generous people. Thank you again, Murph, for that gift sub, speaking of which. Yeah, and Kennedy, you too. Thank you so much, Kennedy, for your contribution. We're using a lot of the gear that today that you helped us buy at the hardware store last night. So thank you again for your donation. We really appreciate that. We've got whisk brooms and awls, and we got some little plastic stoppers on some of the rebar so that we won't impale ourselves on them. That's good to have. In fact, actually, let's put one on right now. I missed this one. Here we go. There we are. There we go. Now if somebody walks by this, they don't risk tearing open their calf or something. Thank you, Kennedy. We appreciate it. From viewers like you? Exactly, Link for real. Yeah. Kennedy says, "You're welcome. I'll skip the bar to fund rebar." Thank you very much. We appreciate it. Yeah. About 10 caps for the crew, says Kennedy. No, and some whisk brooms and some awls and stuff like that. We really appreciate it, Kennedy. It does make a difference. Gotta say, you're making me look really good. When we were there in the store and heard that you'd made a donation, everybody else on the crew turned and looked at me and they're like, "What, Danny? Does this happen a lot?" I'm like, I don't know if it happens a lot, but it happens. Thank you, Kennedy, for your generosity. Really appreciate that. It makes a difference. It really does. Yeah. Yeah. Oh, and thank you, Claire, for reposting that from Nell. Hey, Danny, I've got a friend who is... who's asking a question through me about volunteering for digs abroad as someone who's ex-military. Are there many or any places that the paleontologists need armed protection while excavating? I've now heard of a place in Peru where people were digging titanosaurs. Armed confrontations were something that happened. But is that rare? I want to make sure I give the right info. There are... So I have friends who have worked in conflict areas, collecting fossils. Yeah, I have a friend and colleague who worked in Myanmar, in Burma, and had to have an armed escort provided by the government locally, I think. And she was like, she told me that he was like a 14-year-old kid walking around with a Kalashnikov rifle, and he was assigned to their crew by the government. And they'd be out prospecting looking for fossils, and they'd like play a game every day where they'd like try and lose him. So like, you know, he'd get distracted, or he'd be using the bathroom or something, and they'd be like, quick, let's run over the hill, let's lose him. Anywho, for the most part, we as fossil scientists try not to have to work in areas that are that conflict prone, or we would need armed guards. In that case, I don't think she really needed an armed guard. It was just the government told her that she needed one. Gave her a 14-year-old kid with an AK-47. But yeah, there are places in northern Africa, and other parts of the African continent too, where I know crews who have worked with armed guards. You get bandits and people like that in those sorts of areas sometimes. But for the most part, we tend not to work in areas like that if we can help it. That being said, if you know, Nell, if your friend is ex-military and looking to help out with a paleontological excavation, it doesn't have to be in an armed capacity. You know, we need volunteers of all kinds. They don't have to be carrying a gun. You know, I've got friends and colleagues, people who come out and work with me in the field. You know, who are former Army or Marines. Ken jumps to mind, actually. Paleo Ken, former Marine there. And Ken is an invaluable addition to any field crew. Generally, if you have some sort of military training, it usually means you're pretty comfortable outside. You're okay sleeping in a tent. You're, you know, happy putting up with primitive conditions, you know, pooping in a hole in the ground, stuff like that. And Ken is also remarkably strong, and so he's a good guy to have around. I hope he comes out and joins us here. I hope he can find the time to do that. But yeah, Ken's a good guy, and a former Marine there, U.S. Marine. So yeah, to tell your friend Nell, yeah, they're welcome to try and join up with a field crew, apply to do that, but they don't have to bring a gun. Their help in excavation and data collection would be so much more useful, I think, than, you know, being an armed guard. Yeah. It'd be a lot more fun, too, I think. Yeah. And... yeah. And let's see here. You guys get holes in the ground? Must be nice, says Portager. I mean, we've got something even nicer than that. Luxury back in camp. We've got a river toilet, what we call a groover, which is an aluminum box with handles on the side and a toilet seat on top. That's where we do our... but yeah. Rahab McCullough says also fossil poachers. Yeah, that is definitely an issue in certain parts of the world, but the fossil poachers that we have here in Utah, they're not as, I don't know, they're not going to drive up in a Toyota pickup with a machine gun on the back or anything. It's mostly just like people in the local community who are like, let's go out and dig up fossils, you know, on the weekend. That kind of thing. Yeah.
Yeah, I think over here we're going to start tomorrow with
and over there we're also reach out to Ken if you want to, Nell. I mean, yeah. Yeah, Nell, I don't know. If you were to tell your friend, just... field crews don't normally need armed guards. If they do, they're usually organized by the government or whatever, of whatever country they're in. If you're going to a country that has armed conflict, usually you're in contact with the central government and they send armed guards with you. So I don't think there's a way to be like a gun for hire for a paleontological crew. But if your friend wants to just join a field crew and be a member of the crew and help dig and help collect data, great, you know? They don't need to bring a gun. Yeah.
It definitely is.
Yeah. But yeah. And Golganek, thank you for the bits there. I appreciate that. Yeah. Late fee. Oh, it's great to have you here, Golganek. Interested in going to Mongolia. Oh, cool. Yeah, there are a number of different museums that work with the Mongolians here in North America. There's some Canadian museums, like the Royal Tyrrell Museum, I think, has done some work in Mongolia. The American Museum of Natural History in New York City. And the North Carolina Museum of Natural Sciences, where Lindsay Zano works. They do a lot of excavations in Mongolia, too. So there are different field crews that you could join, but I think generally space is pretty tight on those. So you might want to start off with something a bit smaller time, something like this. Get your bona fides in order, and then you might get invited out to a field crew like that. Yeah. And I don't think we need any infantry fighting vehicles, Crimson Carnotaurus. They use too much fuel, it'd be too expensive. Sell that thing and, give us a portion of the proceeds and we'd be more than... There you go, Just Floof. Let's get that digging. Is that a song? There is a song called Bobcat by the band or artist group, I don't know, called Thesone, Thesone. And it might be like a remix of a commercial jingle or something, but it's a fun little song if anybody wants to look it up. Bobcat by Thesone. My friend Snail Chaser, who streams here on Twitch, that was one of our favorite songs. It's a long story, but he had this thing called the Bobcat movie that he worked on in middle school and high school, and that was the song that ran under the credits.
Danny, want to see something cool?
Always.
So,
What do you got?
there was this bone. It was in the way.
Okay.
So we just ripped it out because it was kind of rotten on one. Yeah, it looked like it flared at one end. Turned skinny, but the skinny end was just kind of rotten looking.
Okay.
So we had to move it to get a jacket off because it was loose already. And then we looked at the cross section, and oh boy, it's hollow.
Oh, theropod?
Yeah. So I think this is
right.
theropod tibia.
Awesome.
Yeah.
Is it going in further? Is there more?
It is. Yeah.
All right.
So,
very, very cool.
Yeah, it was in the way, but now we care a lot more about the rotten end of it.
Yeah. Shoot, can we come look at where it was coming out?
Yeah, it's where Jeff and Alyssa are hanging out.
Yeah. So since I've been talking so much, would you explain to chat what a theropod is and why this is exciting?
Yeah, so this is a meat-eating dinosaur. The thing, chat, if y'all, I feel like I've already said this at one point. If you eat turkey for Thanksgiving, or if you eat chicken on the bone, as you should, as proper chickenivores do, break one of the bones open and you'll notice they're hollow.
Yeah.
So that's not just a bird thing though. That goes all the way back through, their ancestral meat-eating dinosaurs, the theropods.
So that's one of the things that birds inherited from their dinosaur ancestors, from their theropod ancestors.
Exactly.
Hollow bones, yeah.
So it's advantageous for flight.
Yeah.
But obviously shows up well before flight. And what you're looking at there, that little bit is bone, and that's the hollow part that got infilled right there.
Yeah, very cool.
And the way this flares, I think it's tibia. We got a little plaster on it, but that'll buff out in the lab. We've found a couple of metacarpals, so the hand bones, during our excavations of Dromaeosaur.
Yeah.
But this would be the first hand bone from a theropod that we found. There are other theropod bones that the Denver Museum found during their excavations, but yeah, it'd also be the first theropod from this excavation area right here.
Very cool. That's super exciting, Josh.
Yeah.
Thanks for calling me.
Yeah.
It's really fun. Can we see where it came out of?
Yeah.
Good job.
The rest of it doesn't look like much, but
But as we all know, provenance is the most important thing about paleontology.
But it connects really well right there.
Nice. All right.
And yeah, so it's going in through that right there. So that actually looks pretty good. The in between, it's in the soil horizon, so it's weathered and even a little bit rooted. But pods are here.
Yeah.
It is worth saving.
Heck yes.
A new plan just dropped. Work on that bone.
Awesome. Very exciting, yeah. And so cool to find something that's not Gastonia. Not like we're not happy with Gastonia, but
I was going to ask you that.
you know, there's so much Gastonia here that
I hear Susie loves theropods, actually.
My favourite dinosaur.
Your
I'm so
favorite,
happy.
right?
He was the one who suggested breaking it.
Yeah.
Right up there with the term splate. Bagamizer.
oh boy, yeah.
Don't love plates either.
Susie works on mostly on thyreophoran dinosaurs. She might say thyreophoran, actually. I'll have to get her take on the pronunciation. But armored dinosaurs. Let's talk about dinosaur phylogeny real quick, and I'll kind of walk you through, talk about why this critter is so different and why it's important. Since we've got... and Jim says, did I hear theropod with a splate? Jim, it's good that... Here, let me take you through real quick. Jim just showed up. All right. Well, guess who just showed up in the chat? Actually, he said, "Did I hear splate?" It's Papa Jim.
Jim!
Jim Kirkland's
Tell him what
in
we
the
just
chat right now.
found.
Yeah. So got a potential theropod bone right here. It's hollow. Could be a tibia, possibly.
I don't want
But it's hollow there.
Is it a massive...
Just paraloiding it right now.
Nice. Yeah.
I'm not
Make
ruling
sure
it
that
out.
thing
now
gets
that I've
glued
got
up.
that on, right.
But
I'm like,
nice.
what is so round?
It's got an
Yeah.
Yeah, and there's more of it here.
So it's going in. Yeah.
Yeah, and there's this other
Exciting.
one we just uncovered that might be
Uh huh.
something. So it'll make it difficult to get this one out because now we're gonna have to be super careful.
Right.
More so than before.
Everything's getting more complicated.
Yeah.
Jim says he's sitting at Ottinger's. Lynn Ottinger's place? Huh.
I'm not sure
Sitting at
about
Ottinger's. I don't know what you mean, Jim.
You know,
Yeah.
did they ever tell you what they did to me? They buried a small
Yeah.
cast here, our first year. And, like, they said, oh, Josh, you should really dig right here. I was like, okay, fine. And I saw the corner of it, and I was like, wait a second. And then, yeah.
Did you fall for it?
No, well, for about 5 seconds, I was like, that looks like the corner of a ass. Yeah.
Did you lick it?
No, I didn't.
Sweet,
I gave it a big
plastic.
smooch after I re-excavated it.
Oh, Jim's sitting at Lynn Ottinger's rock shop in Moab right now. Okay, cool. Yeah. Jim's here in the chat, wants to say hi to everybody, so...
Hi, Jim.
Yeah.
Hi, Jim.
Hi, Jim.
Yeah. So, we're doing pretty well over here, finding all kinds of different elements, including now a theropod piece.
Theropod.
Exciting. Yeah.
This is the one.
Here, let me,
Here's what happened.
let me go... For all the folks who are maybe not concept, we'll do a little primer on this. Anyway, it's good to see you, Jim. Is your talk tonight, by the way? I think you said the 24th in Moab. Does that mean you're coming by tomorrow? It'd be great to see you, Jim. But yeah, let's talk for a minute. When we use terms like theropod, sauropod, what are we talking about here? These are different groups of dinosaur. And when we're talking about different groups of dinosaur, when we're talking about different groups of organisms in general, we're talking about creatures that are related. So, again, for most of you watching, this might be super, super basic stuff. Maybe you've heard it 1,000 times, but it's important to go over for anybody who's not familiar with this concept, because it's like the fundamental principle in all of biology, basically. Living things are related to one another, and they change over time. This concept of evolution, a family tree. So when a scientist says that, oh, these critters are related to each other, we mean that literally, you know? We mean that they actually shared a common ancestor in the same way that you share a common ancestor with your siblings. You know, you've got the same parents as your siblings, most likely. You're related to your cousins. You share a common ancestor with your cousins. You've got the same grandparents, presumably. Yeah. It's the same. You can go back further and further and further, more and more distantly related until you get to all life on Earth. So we call this concept phylogeny. This is kind of like I said, one of the most important concepts in all of biology. So, different creatures are related to one another. The closer they are, the most recently they had a common ancestor. So, as far as we know, all life on Earth evolved from a single common ancestor about 3 billion years ago. So everything from plants to worms to sharks to mammals to dinosaurs, including birds, they're all related to one another to varying degrees, varying levels of closeness, way back to the origin of life on Earth. And with dinosaurs, we're able to figure out who's most closely related to whom based on shared characteristics. So to a certain extent, the more similar two different kinds of Mesozoic dinosaur look, the more closely related they probably are. I'm oversimplifying things a bit, but we're just talking about this on stream. It's pretty casual. But dinosaurs start right here on this family tree. Everything that evolves from this is a dinosaur. So that's the definition of a dinosaur it's the, Dinosauria includes the common ancestor of critters like Triceratops and modern birds, everything in between, and that common ancestor. So if you're going to use like a crown group definition for dinosaurs, it's the group that includes Triceratops, Passer domesticus, which is a kind of bird, the common ancestor of those two, all of the ancestor. So basically, if you evolved from that first dinosaur, you are a dinosaur. That's the definition. So dinosaurs are very specific, doesn't include things like alligators, doesn't include things like snakes or turtles or lizards. They're other kinds of reptiles. Dinosaurs are a different group of reptiles that all evolved from a common ancestor. That's why they're dinosaurs. Anyway, you get the sauropods up here, big long-necked plant-eating dinosaurs. You get duck-billed dinosaurs and other iguanodontians. They're related to the horned dinosaurs like Triceratops. And then you get the ankylosaurs over here too. Gastonia is a member of this group. It's an ankylosaur. Gastonia doesn't have a tail club. This is a tail-clubbed ankylosaur, an ankylosaurid. But Gastonia is a member of the ankylosaur group in general. And all these different groups are related to one another, and they all evolved from the first, earliest dinosaur here. Does that make sense? So, again, when we're talking about living things and how to classify them, there's a real underlying biological reality there. We're not just talking about vibes. We're not just talking about, oh, these critters, they seem similar, so we're going to say they're related. When we say that they're related, we mean that they are actually related to one another, that they actually share a recent common ancestor. And how recently they had a common ancestor will dictate how closely related they are. Does that make sense? It's all based on that living things change over time. They diversify. It's evolution, baby. That's how it works. Where's my water? I'll put it over here. Yeah, I hope that makes sense. Let's see. And
Do you need something?
And Lord Jeebus says, are there many examples of convergent evolution in dinosaurs? There certainly are, yeah. Here, let me think about that while I'm drinking some water. Try and give you a good example. Oh, hang on, are they getting ready to go? All right. Here, we'll go through the quarry on our way down. But I think our students are getting ready to head back to Colorado for the evening.
Someone was using it as a door holder for their rendering.
All the students getting ready to go?
Yeah, they're heading out.
All right, cool. Yeah. And to give you an idea of how far east in Utah we are, they're heading over to Colorado for the night because it's not that long a drive.
Yeah.
Yeah, cool. I think this went well. Yeah, I'm really happy that.
Yeah. Got a lot.
I hope they all get done too. Yeah. Yeah, good stuff.
That is the fun part of when this big group comes. They expose a lot, get a lot of things out, but expose a lot, and then we have to spend 2 weeks
just feverishly trying to excavate
getting everything else out that got exposed. But
yeah,
it's a good problem to have.
Nice. So. Yeah. Cool. Here, let me.
All right. Have a good night.
Be safe driving.
Have a good night, y'all. Very cool.
Did you say howdy when they rolled up this morning? He did. 3, 4 texts.
All right, convergent evolution in dinosaurs. This is what we were talking about. So there are a number of different groups of dinosaur that independently evolve certain interesting structures. Talk about like a duckbill, for instance. There's the duckbill dinosaurs that leap to mind. Hadrosaurids. But there's also certain groups of iguanodont, like earlier iguanodontid, that develop duckbills, things like Uranosaurus. That might be an independent evolution, or it might be the same thing, I don't know. But then you get a similar kind of bill shape that shows up in dinosaurs like Dinochirus, a big ornithomimid dinosaur, or ornithomimosaur. Yeah, independently evolved a big duckbill type shape to its beak. Lots of examples of this kind of thing where you get similar structures that evolve independently, and we call this convergent evolution. So just because two structures look similar doesn't necessarily mean that they're the same thing, that they show that two animals are super closely related. Yeah, oftentimes, if you have similar evolutionary pressures, if you have a reason to evolve in a similar direction, two different critters can evolve very similar features. That's called convergent evolution. Yeah. And there you go, Crimson Carnothoris. Yeah, so some sauropods like Shunosaurus, they develop like a club at the end of their tail for defending themselves against predators, probably. And we have a tail club that evolves in ankylosaurids as well. And it's interesting. They may have been... They look very different. In ankylosaurs, it seems like the tail club handle evolves before the actual club does. And I don't think that happens in things like Shunosaurus. But it's interesting to think about, you know? Yeah. You get various kinds of theropod dinosaurs that evolved to be with small arms, with a huge head full of really fearsome teeth. You get that in the allosauroids, you get that in tyrannosaurs, you get that in earlier groups of theropods like ceratosaurs. Yeah, and that is convergent evolution. In order for it to be convergent evolution, it has to be independently evolved. So you have to have a similar feature that evolves in different lineages that's not shared by the common ancestor of those lineages. So each of them have to evolve the thing on their own in order for it to be convergent evolution. Does that make sense? So that's the difference between convergence and what we call homology. Homology is where it's the same structure because they both inherited it from their common ancestor. Yeah. But yeah. And let's see. Myolenidae, the spike-clubbed turtles. Yeah, Dr. Did. That's really cool. That's another example of convergence. And those, the myelenid turtles, many of them even develop these weird, like, horn things on the back of their skulls, just like the little hornlet things that you get on ankylosaur skulls. It's pretty neat how that works. These are totally different groups. We're talking about a dinosaur and a turtle. And they're both evolving similar structures like that. Probably because they've got similar evolutionary pressures. They're both defending themselves against predators and developing similar armor and spikes and stuff like that. They both develop clubs on the end of their tails. The ankylosaurids and the myelenid turtles. Really neat. Yeah. And Lord Jeebus says, are there examples of an evolutionary trait appearing, disappearing, and then reappearing down the line? That's a good question and a tricky one to answer. So I immediately think of Dollo's law, D-O-L-L-O. If somebody wants to post a Wikipedia link to that. But Dollo's law, the idea that it doesn't usually evolve in the same way a second time. So chances are, if it be a different kind of structure or something like that. So an example of this, I don't know if this is a particularly strong example, but if you think about pandas, you know, everybody's favorite black and white bear, pandas have a thumb that they use to grasp bamboo and stuff like that, because those guys are just eating bamboo all day long, every day. It's not an actual thumb. The thumb of a panda is actually a wrist bone. So if you see pictures of this, it's wild. It's worth looking up. It's really cool. So the thumb of a panda is actually like a wrist bone. Actually, yeah, this is weird. I've had this bump on my wrist for a while now. I'm not sure what it's doing. But picture this lump right here, but it gets larger and larger and it comes out, and then it can actually oppose with the rest of the hand like that. So they can use this as like essentially a thumb for grasping bamboo. You know, if it were, you know, a wrist bone like that. Really strange. That's not a trait that was lost and then re-evolved in a different way, but it's just, they, you know, sort of a grasping structure. And rather than just using what they already had, using their digit 1, rather than like having their non-opposable digit 1 turn into an opposable thumb, it was easier for them just to evolve a weird wrist bone that's, you know, that can oppose the rest of the hand. Incredibly weird, but that's how evolution works oftentimes. It works way differently from like how you would think to do things if you were planning it out in advance. You know, it's not like an intelligent process. Evolution is fairly random in a lot of ways. And it's just whatever works, works. It's kind of a path of least resistance kind of thing. And oftentimes when you've got features that are lost, like say for instance, I'm trying to think of an example here of, goodness, this would be easier if I were back home in my office and I could pull up videos and stuff to help illustrate this. I'm out here in the field, so it's a bit trickier. But I'm trying to think of an example. Shoot, I don't know. Has anybody in chat got one? Yeah, we're posting pictures. Oh, thank you, Claire. Cool, cool, cool. Yeah. And no other bear has that, Pumpkin the Cat. Yeah, only pandas have got that, that opposable wrist bone. But yeah. Yeah. And panda ancestors were omnivorous? No, that of course that makes sense, Kennedy, yeah. Pandas are a weird outgroup where they evolved to eat bamboo. They became bamboo specialists, but their ancestors would have been more similar to other bears and would have been omnivorous in the same way that other bears are. Pandas are a bizarre offshoot that became hyper-specialized to eat bamboo. There is a niche to be exploited there. There's bamboo all over the place. I guess a panda ancestor started chowing down on some bamboo at some point, and they just got better and better at it over time. They became more reliant on that resource, and they eventually evolved to be hyper-specialists in eating bamboo. Yeah. Oh, and tooth frogs. No, that's a great one, Dr. Tara. Birds. Birds used to have teeth. Birds evolved from dinosaurs, not too different from like Velociraptor or Utahraptor. And the first birds that evolved from those dinosaurs had teeth. Then you had all kinds of birds with teeth during the Mesozoic era, during the age of dinosaurs. Lots of different lineages, all doing their own cool, unique things. And then when that asteroid hits at the end of the Cretaceous, most of those bird groups go extinct. There's only a few bird species that survived that asteroid impact and the ensuing ecological devastation. Birds almost blinked out of existence. There are only a few species that made it through, it seems. And none of those guys had teeth. So later on, when the descendants of those few surviving birds diversify, they kind of take over the air after the extinction of the dinosaurs and the pterosaurs. Birds are all over the place, and many of them move into environments where it would help them to have teeth. If they're feeding on fishes and squid and stuff like that, slippery prey, like, it'd be great for them to have teeth, but that ship has sailed. They already lost teeth. They don't have the requisite structures to evolve socketed teeth anymore. All of that stuff is gone. And so what they evolved instead was just pointy structures in the beak, what we call like pseudo-teeth. I'm talking about birds like Pelagornis and stuff like that. So it's like they convergently evolved teeth, but they're not true teeth. It's just pointy things on the beak. The teeth don't have roots or anything like that. It's just sharp, beaky points. So the pseudo-teeth of pelagornithid birds are a good example of this concept, I guess. So, yeah, does that make sense? I hope that answers your question. Yeah. And whales are an example of this in reverse. No legs, legs, no legs again. Yes, if we're talking about like hundreds of millions of years, Claire, but it's a little confusing. Wouldn't be able to re-evolve legs in the same way, if that's what you mean. Because they've already lost them through their evolutionary history. It's not like they're going to develop... If they develop a leg-like structure again in the future, tens of millions of years from now, it'll look completely different from the legs that their ancestors had. Things like ambulocetids and stuff. So yeah. Yeah. Anywho, yeah. And Dragonfly says, Danny, you're developing a panda pseudo-thumb? I don't know what my wrist is doing there. That bump is weird. It's probably nothing.
Do you have a ganglion cyst on your wrist, Danny?
Is that what it is, you think?
Maybe.
Yeah.
Is it growing?
It... Maybe.
Right there?
Yeah. No, right here.
Right there? Oh, yeah, that's a ganglion cyst.
Oh, okay.
Yeah.
So that's
it's a
benign, right?
Yeah. No, it'll never go away. It'll just get bigger.
Oh, wow.
Yeah.
Okay.
So you have two choices.
Uh-huh.
Well, actually three. One,
Yeah.
you could just leave it and watch it get bigger.
Okay.
Two, you with a phone book or a heavy dictionary and burst it, but it'll come back because there's a little tiny filming what the cyst material arises from. Or three, you can do the doctor route and get it removed.
Gotcha.
Once it starts to really bother you. But it's benign. It comes from your neural tissue.
Interesting.
Yeah,
Okay.
yeah.
So it's nothing related to like carpal tunnel or anything like that. It's just a...
It's just some people are prone to them.
Interesting.
Yeah, I'm not a doctor, but
Yeah.
I would bet that that's what that is.
I think you're right.
It feels
I think I was reading
it feels
about
like a ganglion. It's
Yeah.
kind of spongy.
Mm-hmm.
Mm-hmm.
Interesting.
Yeah.
I might try the phone book thing.
It's going to hurt a lot.
Yeah.
You may have to hit it multiple. You'll need a friend.
Yeah. Okay.
Yeah. We could do it for you in camp, though.
Maybe we'll make a party out of that.
Really,
Yeah.
really huge dinosaur book that I got in Moab that's used, and it's hardback.
Nice. Is that the Dinosauria or?
No, that one's a soft cover. That's not going to do the job.
Oh, okay. Gotcha.
So I got a Greg Paul book.
Oh,
and
nice.
So, it's a thick honker, so.
We might do that later then. Yeah.
Okay.
Thanks,
some beers.
Erica. Nice. Yeah. But interesting. See, this is why it's great to have Erica around. She knows about the soft tissue stuff that I'm absolutely clueless about. So, you know, a good field crew has got different people from lots of different backgrounds and different strengths. Yeah. It's also good to hear that I'm not developing a panda-style false thumb there, like we were talking about. Yeah. And but yeah. Here, let me go get some water. The students have taken off. I hope they had a good time. They'll be back tomorrow. Do you think we could get a stream that delves into the differences in comparisons between carnosaurs and coelurosaurs? Oh, so that's... I guess we could, yeah. It depends what you mean by carnosaur. That's an old term for, like, just any big theropod. Everything from Ceratosaurus to Allosaurus to Tyrannosaurus. They were all called carnosaurs at one point. Nowadays, we recognize that tyrannosaurs are actually kind of coelurosaur. Ceratosaurs are their own thing. So carnosaur, nowadays, I think that refers to... I think it's allosauroids, which includes carcharodontosaurs, and things like megalosaurs might also be carnosaurs as well. I'd have to look it up. But yeah, we can talk about that at some point if you'd like. Yeah, we can do that. And Pumpkin the cat says she is hardcore. Erica, yeah. Let me tell her you said that. I think she'd appreciate that. Yeah. And where did they fly into, the Brits? Denver? I think they did fly into Denver, Kennedy, but I'm not totally sure. Yeah. Yeah. And Mm-hmm. Here, Erica, we had a chatter say with regards to you, she is hardcore. If there's a zombie apocalypse, I'm sticking with her.
Dude, you're on my team. On my team.
Nice. No, Erica's great to have around for sure. And let's see, Beast Mode indeed. Yeah, that's her field name. Yeah. Oh, I was gonna get some water. Let's do that. And I can't believe it's only 5 o'clock. Shoot. I feel like we've been streaming for so much longer than that. I think part of what's throwing me is that it's getting late in the year here. It's late September already. And that means the sun sets earlier and earlier every night. I'm not used to doing field work at that time, so I'm like all discombobulated. I'm like, oh, it's got to be 7 o'clock already. Like, nope, it's not even 5 o'clock yet. But yeah, again, I'm used to this mode where if I'm in the field, it's the height of summer. Nope, not right now. Yeah. Will Jim be streaming his talk later tonight? I don't think. Although Jim does have a bunch of other talks up on YouTube. If you'd like to see, Papa Jim, give a talk, there's a bunch of them saved for posterity on YouTube, including some that I need to watch soon. But yeah. And October isn't just a few days, yeah. October 1st will be my last day streaming from here at this site, according to a current plan. There is a slight chance, and I guess I can share this. There's a slight chance, maybe a 5% chance, I don't know, I quantify these things, that I'll be leaving here a little bit early, a couple days early, and maybe rushing home to do some leatherback turtle field work, which I would not be able to stream, I don't think. But, yeah, slight chance. But everything has to line up just perfectly for that to happen, and I don't know how likely that is. So, yeah. There you go, Kennedy, yeah. And from Luke Herman's Gaming, how do you think paleontology would be like today if Jurassic Park ever existed, in the sense of its impact and popularity, not scientific accuracy? That's a great question, Luke Herman. I've talked about this before. Jurassic Park, the novel, and especially the film, were a boon for dinosaur science. Really, really good for our field. In fact, if we have Jim here tomorrow or something, I'd love to be able to ask him about this on camera. So the way that Jim tells it, back in the late 1980s, there were hardly any jobs for people who wanted to study dinosaurs. There's still not very many today, but Jurassic Park pretty much doubled the number of jobs available in paleontology almost overnight. Suddenly, with a big resurgence in public interest in dinosaurs, museums are like, well, shoot, we need to build dinosaur exhibits to get people in the door and start, making money for our institutions. We need to hire some people who work on dinosaurs. So suddenly, you have all of these jobs that appear for people who work on dinosaurs. It's not very many, but, probably, maybe twice as many as existed before, which was really significant. Yeah, I think Jim said that on average there was maybe one dinosaur-related job that would be listed every year. So a museum curatorship or a professor of paleontology, something like dinosaur-related like that. Dinosaur-specific. There'd be maybe one per year, something like that. And afterward, they're a bit more common. A bit more. Going from 1 to 2 is it's 100% increase. That's kind of what happened with Jurassic Park. And there was a bit more funding for dinosaur science. There's, you can pretty much directly trace organizations like the Jurassic Foundation or the Dynamation Society, they were kind of born out of the Jurassic Park craze to a certain extent. I know Dynamation came earlier, but they really grew in the wake of Jurassic Park. And so it's been really good for our field in general. I don't feel necessarily like Jurassic World has had that same influence. Anywho, we'll talk about that another time. But, yeah. It's interesting in that a lot of this stuff can be traced back to one guy, to John Ostrom, back in the 1960s. The whole Jurassic Park craze, I think, probably wouldn't have happened without John Ostrom, who his crew discovered, or at least excavated, and then published on Deinonychus, the terrible claw. That's the velociraptor from Jurassic Park, is actually Deinonychus. And so Michael Crichton, in learning about dinosaurs in the 80s, he was inspired by animals like Deinonychus. He called it velociraptor in the book. And a bunch of the ideas of people like John Ostrom and his students are, these were ideas that appeared in the novel and then in the movie, and it kind of rekindled John Ostrom describing Deinonychus and showing that dinosaurs were oftentimes active, intelligent, possibly warm-blooded, bird-like, dynamic animals. It kind of gave dinosaurs a new lease on life in terms of scientific study. Suddenly, they were a worthy object of research. Dinosaurs were kind of a scientific backwater for a long time, and then John Ostrom starts talking about Deinonychus and is able to demonstrate how cool this animal is, and that led to more scientific interest in dinosaurs, which led to more scientific discoveries, which led to more publicity around dinosaurs, more public interest. That led to Jurassic Park, and then just a huge explosion in public interest in dinosaurs around that time. A number of people here in the quarry right now, or students that we had here just a few moments ago, if you were to ask them, like, how did you first get interested in paleontology, I bet the name Jurassic Park would come up more than once. It's been really influential. So it's overall a really good thing for our field. And yeah. My old boss, when I worked at Museum of the Rockies, Jack Horner, he was the scientific consultant on the Jurassic Park films, the first 3. And that's part of why he was able to establish Museum of the Rockies as a dinosaur science powerhouse in the 1990s and the early 2000s. And in large part, that's why I'm here right now, talking to you, is because of that, you know. You can trace a lot of it back to John Ostrom, back in the 60s, and Deinonychus. Really important. Yeah. And watched the first Jurassic Park movie in the theaters when I was a kid. In its aftermath, there were new exhibitions, dinosaur-shaped cookies, cereal, big selection of dinosaur toys in stores, many types of species represented. Absolutely, yeah. Yeah. And Murky Gray says, how often do you apply sunscreen? I put a lot on this morning, but I haven't done that recently. I could do that again real quick, but angle of the sun's getting pretty low. It's less direct. It'll be fine. I've been digging dinosaurs since 2011. I spent a lot of time in the field. I've never gotten a truly catastrophic sunburn. I've been very lucky like that. A little of it might be real, but a lot of it's just going to be from the camera. Yeah. And Jim says my October 16th talk will be streamed. Very cool, Jim. All right. Nice. That is really good to hear. How did I miss that in the chat? Yeah. Here, let me look. And Jim says Bacher and Horner. Yeah. Yeah. And Jim says about Dynamation, we went belly up a few years later. Yeah. Yeah, but that was due to foul play rather than lack of public interest. as I understand it. There was some mismanagement at the top of that organization. You've told me about this, Jim. Yeah. Jim, when are you coming out here? It'll be great to see you again. And even lighting is a good reason for shade tarps, says Jim. It's true. Yeah. We were just talking about that the other day, why we, exert all this effort in putting up these shade tarps like this. Here, Jim, let me show you around some of the things that we've been finding lately while you're watching, because I know you'd like to see this. That's Utah State paleontologist Jim Kirkland in the chat, everybody, in case you're wondering. But yeah, guy who named Gastonia as a genus. Gastonia lori-mcwinnii, I think, was a Carpenter publication, right?
Billy Kinnear and Carpenter.
Okay, yeah.
Alan Shaw.
Nice. But yeah, here, check this out, Jim. I don't know if you saw this earlier, but beautiful big osteoderm right there, big old spike. And then there's another big one right here too. That seems to be plunging under this guy. We've got ribs right here. Lots of osteoderms just scattered all over the place. This, what were we saying, ischium for this right here?
Think so?
Yeah. Hip bone. This could be a tib right here. Tibia potentially. Just giving Jim a tour of this so far. Another big rib right here. This is our longest bone in this part of the quarry so far. That looks like it might be more rib right there. And then we've got verts and stuff. Just osteoderms everywhere, as you would expect. Another rib over there. Yeah, good stuff. And then there's lots of big elements over in the other pit, too. Yeah. How many specimens are we up to now so far this season? We have
well, just that have come out. Let's see, I've got...
Oh, nice.
20...
We logged like 23 on our end or something. 24.
Not too shabby.
Yeah, 24 over here and 6 or 7 over there.
Nice.
So,
very cool.
Yeah, I mean, that's mostly been today. So, yeah, well, now that we've got things exposed, we're cooking. We pulled one jacket. We'll probably pull another 1 or 2 tomorrow.
Nice.
Over there. So,
excellent.
Yeah.
0 to 100 real quick.
Yeah. Whiplash. And the Brits are here tomorrow and Friday morning?
Yeah, most of Friday. I think till,
cool.
what'd they say, 2 or 3, something like that.
Gotcha.
Or maybe, sometime just after lunch.
Cool. Nice.
And then they head to Price.
Okay. They're checking out the museum. Are you taking them there?
No, I'm still going to be here. So,
okay, cool. We don't lose you. That's good.
No.
Yeah.
No, I don't leave till Sunday night.
Gotcha. Yeah. Cool. Yeah. Let me go and walk around a bit more.
That's a good idea.
Yeah. And Jim says, see you tomorrow, but I have a mission. All right, Jim. Cool. We'll see you tomorrow. That's going to be great. Yeah. I wonder if you'll be here while we're streaming. That'll be 2 p.m. to about 6 or so. Yeah, in fact, I might even wrap things up a little bit early in terms of today's stream, because I'm a little tired, to be honest. Yeah. And there you go, Luke Hermans, yeah. I was doing the same thing when I was a kid, pretending to be a velociraptor. Yeah. Let's turn these solar panels around too to maximize our coverage. There we go. How are we battery-wise? Display 82%. Okay, not bad. Not bad at all. Excellent. Good stuff. Yeah. And Smoothstone says, I wonder, or should I say assume, that there were paleontologists involved as consultants with many of those dinosaur toys? In some cases, yeah. I think it's actually kind of rare for actual paleontologists to be consulted, but oftentimes the sculptors and people who are designing these, often they'll consult the original scientific literature, they'll consult different illustrations and stuff, skeletal drawings. Like this Gastonia that I have here is pretty well done. There's a few things that Jim would probably change about it if he had his druthers. But for the most part, some of these are really, really good stuff. And yeah, I do know of at least one concrete example of paleontologists being hired as consultants, or maybe not hired, but consulting on toy production. And that was the Carnegie collection from Safari Limited. These hard plastic dinosaurs, generally pretty high quality. Remember Matt Lamana, friend of the stream and curator of paleontology at the Carnegie Museum, Pennsylvania. Matt Lamana worked with Safari Limited Carnegie collection. It had like the museum's stamp of approval on it. And yeah, I think they've discontinued the Carnegie collection though. Safari Limited doesn't do that anymore. I think the museum actually saw some proceeds from that too. Like they were making some money on these toys. And I think for whatever reason they don't do it anymore. I think the company had a change of ownership or something. But yeah, that was mostly way before Matt, says Jim. Yeah, I wonder who was the consultant on those before, because I think Matt said he was there for the last few years of the Carnegie collection before that line was discontinued. I know he was disappointed by that. There were a few different dinosaurs that he was able to consult on. I forget what they were. Yeah. And Natalie Storm says, keep those toys, they become collectibles. Oh yeah, for sure. Yeah. And here, do we have a feathers question? Let's see here. And Luke Herman's Gaming says, I'm not sure if it's called feathers in English. T-Rex displayed with feathers in shows nowadays, but every T-Rex in every video game, movie, or whatever looked exactly like Jurassic Park version. Oh yeah, Jurassic Park had a big influence like that. Yeah. We don't know if Tyrannosaurus in particular had feathers. I suspect that they probably did when they were young, and maybe they lost them over time. We've talked about this many times. Sort of like how baby elephants are way fuzzier than the adults. Baby elephants can be pretty hairy, and then they tend to lose that integument, that pelage, over time as they grow and mature and they get bigger. When you're a smaller animal, it's more difficult to keep warm, and so it really pays to have some sort of insulation like that. But the bigger you get, the more thermal inertia you have, the easier it is to retain your body heat, just because you've got a lot of mass, and you've got less surface area compared to your mass when you're really big. Smaller animals tend to lose heat a lot more readily. They have more surface area compared to their mass. So they tend to be a bit fuzzier or fluffier in terms of feather, all that stuff, you know? So yeah, I think if I had to guess, I'd say, yeah, baby tyrannosaurs, they're probably pretty fluffy. They probably would have had some sort of proto-feathery thing going on. Adults, I don't think they would have needed that anymore. Maybe they had little tiny bristly feathers like you see in Prehistoric Planet, where there's just this thin wisp of proto-feathers, almost like the hair on an adult elephant. It's like, if you look real close, you can see it, but otherwise it's very subtle. Yeah, I actually really like the way that they handled that, where the babies are fuzzy and the adults not so much in Prehistoric Planet. I thought that was a high point. I like that a lot. Yeah. And we have skin impressions from Rexes that don't appear to have feathers. Yeah, but that's just from part of the body. It's really patchy. And that might not, sure, they don't have a full coat of full body feathers. But if there were little bristles in between the scales or whatever, if there's just like little proto-feathering there, that probably wouldn't show up in those impressions. And I also don't know how well studied that really is. So yeah. Anywho. Well, that said, we've been streaming for 3¼ hours, and my shoulder's starting to hurt. I want to be able to help out the crew. We're going to do some, probably do a little meeting now that the students have left. And so I'm going to go ahead and wrap up the stream and help out with that. But yeah. I got to make sure to get some good sleep tonight, so I'm not as tired tomorrow. Anyway, with that being said, let's find somebody to raid here. Don't go away just yet. We are going to see if we can find somebody else doing some science. And let's see if Rhacodactylus is on. He is. Still doing his partner push. I know we raided into him yesterday, but he's doing some science tonight. And so it is an excellent time to go raid in. So let's do that. Again, let's go show Reiko some love and help him with that partner push. Raid. Reiko. _ Dactylus. Beautiful. Right, so Rhacodactylus is a cognitive scientist. He's a researcher who studies why, from like UFO conspiracies to flat Earth stuff to, even stuff like evolution denial or vaccine denial, stuff like that. Really important in this day and age. And on Wednesday nights he does science content, so he talks about this stuff. So we'll see what we're getting up to tonight. Should be cool. Everybody, thank you so much for tuning in today. I really appreciate your viewership, your excitement, your enthusiasm, your questions, your financial support. That's what keeps me here on the air. It's what allows me to do this outreach full time, and I could not be here without that. So thank you very, very much. From the bottom of my heart, I really appreciate the support. Thank you to the moderators, too, who keep this a safe and welcoming community for everybody. Again, you are essential, mods, and I really appreciate your dedication and your hard work. Thank you very much for that. That said, I'll be streaming again tomorrow with any luck, and we'll see what else we uncover. It's going to be a good time. So take care, everybody. Let's go right into Rhacodactylus, and I'll see you there briefly. Take care. Bye-bye.